Dear colleagues, let's start. I'm Tatiana Lovorchenko, General Chair of the 6th International Workshop on Intelligent Information Technologies and Information Security Systems, IntelITSIS 2025. Thank you all for participating in our workshop, for your interest in papers. I am glad to welcome all of you to our workshop, but unfortunately online, not within the walls of Khmelnytsky National University. Sixth International Workshop on Intelligent Information Technologies and Information Security Systems is organized by Computer Engineering and Information Systems Department of Khmelnytsky National University with the support of the public organization Ukrainian Scientific and Educational IT Society. IntelITSIS 2025 focuses on all technical and practical aspects of the latest research and results of international scientists, practitioners related to intelligent information technologies and information security systems. This workshop provides opportunities to exchange new ideas, to establish business or research relations, to find global partners for future collaboration, for future scientific collaboration. I hope that the workshop results make a significant contribution to the development of intelligent information technologies and systems. The program of our workshop includes welcome and plenary session today now, two sections. Section first, intelligent information technologies, which will take place today according to program from 9:15 a.m. after welcome session till 2:45 p.m. And section second, systems of information security, which will take place today according to program from 2 p.m. till 5 p.m. As well as awards and close ceremony, which will take place today from 5:15 p.m. I invite everyone to attend all the events of our workshop, all session our workshop. I wish everyone fruitful work and interesting presentations. Welcome. Now, next speaker who will say greetings words is Professor Oleg Senyuk, Vice Rector for Scientific Work of Khmelnytsky National University. Welcome, Oleg Nikolaevich.
Good, thank you. Good day, esteemed conference participants, organizers, and all present. I am pleased to welcome you to the 6th International Workshop on Intelligent Information Technologies and Systems of Information Security. Last year, the Department of Computer Engineering and Information Systems held 3 conference workshops, the materials of which were published in SIOR. The submitted publications have been indexed in Scopus and Web of Science. I extend my gratitude to the team of the Department of Computer Engineering and Information System led by head of the department, Associate Professor Olga Pavlova, and Dean of the Faculty Information Technology, Professor Tatiana Lovorchenko, for the significant contribution to the university's scientific activities, including organization of various scientific events, the publication activity, and the active participation in international grant projects. In today's highly competitive environment among institutions in Ukraine, the result of scientific and technical activities must have practical value, scientific novelty, and must be implemented in production and published in well-known international journals. Our university has powerful research and production laboratories and research centers of various profiles. Fundamental and applied research is conducted in many priority areas of science and technology. A priority direction of scientific development at Khmelnytsky National University is increasing the volume of service and developments carried out under contract and international grants, publication activity, and the development of student scientific work. Ukraine, and particularly our university, still has many scientists with significant potential knowledge and skills, vast practical experience, and the ability to think critically and evaluate any process. The main task of our university is to create conditions for researchers to realize all their interesting project and to develop our university to a modern world level. The opportunity to publish the results of their research at conferences of this level, such as today's, allows integration into the global scientific community. I sincerely wish with all participants to have many interesting reports, engage in constructive discussions, and take away something new. Thank you for attention.
Great, thanks. Next welcome speech will say by Professor Sergei Lysenko, Khmelnytsky National University, International Program Committee co-chair. Welcome, dear Sergei.
Dear colleagues, guests, friends, it's my great honor to privilege to welcome to IntelITSIS workshop. Firstly and foremost, we begin with this event with deep gratitude to Ukrainian armed forces, whose courage, sacrifice, and resilience make it possible for us to gather today in peace and safety. Our workshop has grown over years into a powerful platform for collaboration, innovation, and inspiration in the field of intelligent information technologies and system of information security. IntelITSIS is more than just a scientific event, it's a statement of resilience, progress, and unity. We believe that ideas shared here today will not only contribute to the global scientific community, but will also have a tangible impact to the technological advancement of security of Ukraine and beyond. We encourage you to take full advantage of this opportunity to exchange ideas, ask questions, and find future collaborations. Let today to be the beginnings of new partnership, new visions, and new solutions to change ahead. Thank you all for being here. Let's make this memorable and impactful event. Glory to Ukraine, glory to heroes. Let our workshop begin.
Thank you, dear Sergei. Next speaker who will say greetings words is Dr. Olga Pavlova, Khmelnytsky National University Organizing Committee co-chair. Welcome, dear Olga.
Thank you. Good morning, dear participants of the 6th IntelITSIS workshop. It's a great honor for the Department of Computer Engineering and Informational Systems to host such a great scientific event year by year. Thank you all for participating, and I wish you all a fruitful workshop, an interesting discussion, and a great day.
Thank you, dear Olga. Next welcome speech will say by Doctor of Sciences Elizaveta Gnachuk, Khmelnytsky National University, Organizing Committee co-chair too. Welcome, dear Elizaveta.
Dear colleagues, we are pleased to welcome you to our workshop. We hope you are safe. Thank you to the Armed Forces of Ukraine for the opportunity to live and work. I wish us effective work, interesting presentation and discussions. Thank you. Welcome.
Thank you, dear Elizaveta. Now we will have the following presentation about IntelITSIS 2025 trends. I am a speaker. Now I will share my presentation. Okay. Sixth International Workshop, IntelITSIS 2025, is organized by Computer Engineering and Information System Department of Khmelnytskyi National University with the support of the public organization Ukrainian Scientific and Educational IT Society. IntelITSIS 2025 was originally planned to have a physical location, Khmelnytskyi National University. However, Russia's war against Ukraine thwarted all plans. Unfortunately, now this event is conducted remotely in video conferencing format using the Zoom platform. For the 6th year in a row, we have a situation where we can't meet live, but have to use only online communication. And I believe that Ukraine will win, and next year we will meet in Khmelnytsky, live in our picturesque city on the Pivdenny Bug River, in the walls of our native Khmelnytsky National University. I offer a moment of silence to honor the memory of all the dead civilian and military Ukrainians. Dear colleagues, we remember everyone who died in the Russian-Ukrainian war. And now we would like to thank the armed forces of Ukraine for providing security to perform this work. This work has become possible only because of the resilience and courage of the Ukrainian army. Thank you for being alive and for living in a free Ukraine. General chairs of the 6th International Workshop on Intelligent Information Technologies and Systems of Information Security are me, Professor Tetiana Govorushenko, and my colleague, Professor Oleg Savenko, Khmelnytskyi National University. Chairs of the International Program Committee are Professor Sergei Lysenko, Khmelnytskyi National University, and Dr. Peter Popov, City University of London, United Kingdom. Organizing committee chairs are Dr. Olga Pavlova, Khmelnytskyi National University, and Doctor of Sciences Elizaveta Gnachuk, Khmelnytskyi National University. International Program Committee has 28 members. 100% of the IntelITSIS 2025 International Program Committee members have more than 15 DBLP papers. There are the representatives of 6 Ukrainian universities and of 13 universities from around the world: United Kingdom, USA, Austria, Slovakia, Czech Republic, Egypt, Poland, and Estonia. 6th International Workshop IntelITSIS 2025 received 74 submissions from Ukraine and the world. All papers were evaluated by 2 or 3 reviewers. And based on these reviewers, a rating of papers was compiled, and papers with positive scores were accepted for presentation at the workshop. According to the decision of the International Program Committee, 29 papers were accepted for presentations at the workshop today. IntelITSIS 2025 joined scientists from Ukraine, United Kingdom, USA, Slovakia, Czech Republic, Austria, Poland, Estonia, Egypt, Algeria, and China. In general, the representatives from 21 universities from around the world and 18 Ukrainian universities. Summary, 39 institutions took part in our workshop. On the slide, you can see list of universities, the representatives of which will take part in workshop today. So final acceptance rate is 39%. I wish everyone fruitful work and interesting presentations. Welcome. We invite all guests and participants of the workshop to take part in the discussion and section sessions. And now we will have section first, Intelligent Information Technologies, which will take place according to program till 2 p.m. Dear colleagues, let's start. Our first presentation is method of pre-processing information for preparing a description of art objects using artificial intelligence by Oleg Voicher, Olga Govorushenko, Artem Boyarchuk, Yuri Voicher, and Anatoly Nested. Who is speaker? Oleg?
I'm speaker.
Welcome.
Can I share my screen?
Yes, you can.
Thanks. So all see my presentation in screen?
Yes.
Yeah.
So today I want to present my work, a method of processing information for preparing a description of art object using artificial intelligence. So AI-powered art assembly. Sorry. Can I continue? It's one moment. I have some mistakes. Continue. AI-powered art accessibility, transforming visual art of the visually impaired. Modern artificial intelligence is revolutionizing the way we interact with art, offering present opportunities to analyze and describe artworks. Generative AI automates the creation of textual description for paintings, sculptures, and other art forms, significantly enhances the accessibility of cultural heritage for the visual impaired. This presentation will explore methods of processing information from preparing AI-generated description of art object. Embracing personality and inclusivity, we will present research on gender-oriented prompts to create personalized description of Vincent van Gogh paintings, Starry Night, and Leonardo da Vinci Mona Lisa. The goal is to create an accessibility art environment for people with visual impairments, bridging the gap between visual art and tactile of auditory experience. So I give word to Olga Vorushenko. She says her section in this presentation. It's psychology. So please, Olga.
Okay. The physiological basic of attention is a process of excitation and inhibition and peculiarities of their mobility and interaction in the cerebral cortex. The directionality of higher nerves and mental activity is always associated with the excitation of some cortical areas and the inhibition of others according to the law of induction. The person's focus of attention may differ by gender, due to biological, cognitive, and social factors. Men and women can perceive and interrupt art differently, paying attention to different aspects of works. This is due to the influence of social, cultural, and psychological factors that shape their aesthetics, preference, and perceptions. The next, please. The key factors influence the characteristics and focus of attentions are hormones. Estrogen and testosterone levels can affect cognitive process. For example, estrogen improves verbal memory and the ability of multitask, while testosterone promotes focus on a single task. Evolutionary features. Some researchers suggest that historically women have developed disturbed attention skills due to the need to care for children and to manage the household, while men have an advantage in narrow focus for hunting of the weapons. Social and cult expectations influence how men and women develop their attention. For example, girls are more likely to be taught to be attentive to the emotions of others, while boys are more likely to be taught to be attentive to technical detail. Neuropsychology. MRI brain scans show that women have more active areas related to verbal communication, and men have more active areas related to spatial thinking. This may explain the difference in attention span. Personality traits, regardless of gender, peoples differ in their attention types, concentrated, disturbed, selective, etc., due to genetics, experience, and professional activities. The next, please. Okay. Characterized by disturbed attention, they are able to concentrate on several tasks at the same time, multitasking. They notice small details, nonverbal cues, and emotions of the interlocutor better, focus on interpersonal interactions, relationship, and nonverbal communication. Notice changes in the environment faster, especially in social or emotional aspects. The next, please. Men have a stronger ability to tunnel vision, are better at spatial orientation, noticing global structures and directions, tend to pay attention to logical connections and mechanical details, may be less emotional about facial expressions and gestures.
Sorry, I lose.
This.
It's slide from woman.
Slide number 9. Okay, thank you. Painting description for movement. The painting radiates tenderness and depth. Every stroke conveys the elegance or details. Soft colors create an atmosphere of peace and harmony, and smooth lines add emotional warmth to the composition. An important role is played by the play of light and shadow, which emphasized and subtle shades of feelings. The heroine is filled with inner peace. Her gaze is mysterious and her posture is natural and relaxed. The painting seems to invite personal reflection, awakening, memories, or dreams. Painting description for man. The painting impresses with its dynamics and compositional balance, contrasting colors and sharp lines create the effect of deeps, and the accuracy of the details add to the realism. The central image of the main figure stands out due to the light and shadows accents, which makes the scene lively and full of character. There are no random elements here. Every detail is subject to the general idea, creating a strong visual effect. The painting arouses interests in the details and techniques of execution, encouraging a logical analysis of its content. The next, please.
I think it's my section now. It's a method of processing information for preparing a description of art object using artificial intelligence. So we have a simple image. Yes, we took this image to artificial intelligence, and what we do. First, data collection and pre-processing. Collection of digital of 3D image of art object, accompanying metadata and available description from various sources. Processing of text, graphics and metadata, data cleaning and normalization, data formatting. 2. Image segmentation. Division of an image into areas that differ in certain characteristics. These areas correspond to real object of or their parts, and their boundaries coincide with the contours of the object. Image analysis, computer vision and image analysis method can be used to obtain comprehensive information about the painting, object recognition, color scheme determination, structural analysis, contextual analysis. Identification of key characteristic of the art object, analysis of shape and composition, color analysis, texture analysis, object-oriented analysis. Semantic analysis and classification, defining categories, gender, style, techniques, using neural network classification methods. Determination of the target audience for further adaptation to 4 different categories of user. For example, taking into account the gender, scientific research, museum catalogs, educational materials, popular resource, woman or man, choosing the style and tone of the text. Generative AI, artificial intelligence can adapt the style of the text depending on the task. Formal style, descriptive artistic style, commercial style, etc. Generating the structure of the description, determining the title, author, year of creation, building a general compositional scheme with a description of key elements. Forming the sub-native part of the description, determining the main plot of the work, detailing the elements of the painting, including a description of main object and their mutual arrangement, revealing the meaning and emotional component of the work of art, analyzing the color palette and painting style, ensuring adaptation for people with visual impairments, using accessible description of paintings and adapting them to the standards of inclusive description, formulating clear and detailed text explanation for audio description, using terminology that contributes to the precision of the texture, shape, space, and emotional coloring of the depict. Developing a language model prompt for automatic generation of text description, configuring generative artificial intelligence to create natural and meaningful description, training the model on a large volume of artistic descriptions that take into account style, historical context, artistic means, using quality control methods to check the accuracy and correspondence of the description to the original works. Output language model prompt for automatic generation of personalized text description of art object. Tailoring art audience-centric adaptation. Adapting art description for diverse audience, especially people with visual impairments, requires careful consideration of individual needs and preferences. This personalization enhances the engagement and reveals of the description. Key considerations include defining the target audience, choosing style and tone, structure the description. Inclusive art, accessible description for all. Ensuring the accessibility for people with visual impairments involves adhering to inclusive description standards, clear, detailed text explanation, and crucial for audio description. Using terminologies that conveys texture, shape, space, and emotion calling, some best practices include clarity and detail, sensory language, inclusive terminology. So we have two results. One result is text generative AI to women. The result of completing the prompt to create a personalized and emotionally colored description of the painting The Starry Night by Vincent van Gogh for women with visual impairments. And second result is of completing the prompt to create a personalized description of the painting The Starry Night by Vincent van Gogh through the prism of history, extension techniques, and artistic style for visually impaired men. Тобто we have two different result to different gender. So, segmentation for personalized description. So, segmentation for women. Green segment, face and hair. Yellow segment, hands and clothes. Blue segment, background in surrounding. So, you can close this, see close this segmentation for women, and this segmentation for men. So in future we want to create to transform to the image to 3D. So people who have visual impairment can touch the paint and listen our description and feel this painting. So maybe someone have questions.
Thank you, Oleg and Olga. Questions, please, dear colleagues. Colleagues, questions? What practical aspects, practical implementation of your method, of your work?
It's creates some comfort transform image to 3D form in people who have some problem with eyes can touch and can understand how its look, how its feel, its shape, and more detail.
Thank you. More questions, please? No more questions. Okay, thank you. Next presentation is detection of military targets from images using deep learning models by Dmitro Borovek, Alexander Barmak, and Yuri Krak. Who is speaker? Dmitro, yes?
Yeah, good morning. Let me share my screen. Yeah. Can you see my screen?
Yes.
Fine. So, good morning, everyone. Today I'll present our research on the detection of military targets from images using deep learning models. The increasing availability of high-resolution satellite and unnamed aerial vehicles imagery has made automated target detection an essential tool for military and defense operations. Traditional methods of target recognition are often slow and prone to human error. However, the deep learning models, particularly CNNs, demonstrated superior performance in object detection and classification. Our research introduces a novel sequential classification approach that implements accuracy and efficiency in detecting military assets. Proposed method. Our approach is based on a sequential classification method utilizing the most advanced YOLO V11 models and faster RCNN. Instead of using a single multi-class model, we divide the detection process into 3 levels, each handling fewer classes, is thus improving feature extraction and classification accuracy. On the first level, we use faster RCNN to detect and classify objects into 2 categories, person and military vehicles. Detecting human figures in images is particularly challenging due to variations in appearances, but faster RCNN excels in recognizing small and complex objects. On the second level, the detected military vehicles is further classified into 3 categories: tanks, infantry fighting vehicle, and other vehicles using YOLO V11M model. These vehicles are common in modern warfare, and training a neural network on a balanced dataset enhances classification accuracy. On the third level, the other vehicles category is refined further into trucks and multiple launch rocket systems and other vehicles. Using the smaller YOLO V11S model, this approach ensures precise identification while maintaining high processing speed. By structuring the classification in steps, we allow each model to specialize in a smaller set of categories by leading to improved recognition accuracy. We evaluated our approach using datasets specifically prepared for each classification level. Let's go through the performance metrics. On the first level, we used faster RCNN. You can see the metric results on the slide. On image, you can see that our model detects possible targets and splits them into 2 classes: people and military vehicles. On a second level, we use YOLO V11M model. You can see also metrics from a metric result on the slide. On image, you can see that our model refines class military vehicles from first layer and classify these objects, especially defines track class. It's a tank class. Yeah. And on a third level, we use the YOLO V11S model. You also can see metrics result on the slide. On image, you can see that our model refines class military vehicles from second layer even more and classify these objects, especially defines car class and leaves unclassified objects as other vehicles. As we can see, the performance remains consistently high across all levels, indicating that a sequential classification approach is effective in distinguishing military targets. Comparison with existing solutions. To validate our method, we compared it with traditional multi-class classification approaches. Our sequential method model showed better accuracy in complex scenarios, particularly in distinguishing similar objects like tanks and infantry vehicles. The ROC curves confirm that our model performs well across all classification levels. The system was trained specifically on WAV images, making it well suited for real-time applications. Limitations and further work. Despite its advantages, our approach has some limitations. The first one is image resolution. The performance of our model decreases when processing low-resolution images. And the second one is limited object categories. The current classification structure only supports predefined set of military objects. To improve this, we plan to expand the classification hierarchy and add more categories, more layers, and improving model performance on low-quality images. In conclusion, our research introduces a sequential classification method for military target detection using faster RCNN and YellowV11 models. By breaking down the classification into multiple stages, we achieve a higher accuracy compared to traditional approaches. This work can be further developed and broadened applications in defense and security. Thank you for your attention. I'm happy to answer your questions.
Thank you, Dmitro. Colleagues, questions, please. Colleagues, I have some question. Why do you use deep learning models? Could you have used some other models, maybe?
Yeah, of course. Machine learning models also suitable for this task, but deep learning models creates features, maps, but by themselves, and our approach allows to use reinforcement learning to also retrain our models on their results during experiments. So and of course we don't have to create features maps for these models. They will do it by themselves.
Thank you. Colleagues, more questions, please? No more questions. Thank you. Next presentation is Fuzzy Model of Knowledge Assessment and Inclusive Education Information Systems by Bogdan Durniak, Petro Shepita, Lyubov Tupechak, Arsen Sivak, and Alexander Bogonis. Who is speaker?
Thank you. Can I start?
Yes, you can.
Thank you. One moment. Can you see?
Yes.
Thank you. Let's start. Welcome all participants of the conference. We will present our research on the topic Fuzzy Model of Knowledge Assessment in Inclusive Education Information System. And introduction. Modern educational systems are increasingly oriented toward personalized learning, taking into account various cognitive characteristics and the preparedness level of learners. An information system for inclusive learning environments implementing fuzzy knowledge assessment models in a particular important. They help eliminate barriers in the learning process, reduce subjective influence from instruction, and enhance the adaptation to education, connect to learners' needs, and open us opportunities for the develop of automated decision support system in education. The main goal of the study is to develop and validate an adaptive model based on fuzzy logic for assessing knowledge in inclusive education information system aimed at reducing sensitivity, effectively managing unsustained and incomplete data, and environment fans and adaptability in accessing individual content characteristic of students. And on analysis of exist research allows a common trend toward the introduction of inclusive practice and adaptive knowledge assessment method. Although the direct application of fuzzy logic of other advanced algorithms and method in knowledge evaluation is not yet widespread, the overarching movement towards individualization and flexibility in education critics particulars for the further development and implementation of such approach in inclusive education system. Considering
Yeah,
the
I'm sorry. We can first slide. Is okay?
oh, sorry.
Oh, turn and slide. Oh, okay.
Now it's okay?
Yes, now we
Okay.
can
Maybe
see
it's a
third slide.
little technical problems. I'm so sorry. Yes, considering the discussed aspect reach on a fuzzy knowledge assessment model in the context of inclusive learning information system in both relevant and necessary material and matters. The study explores theoretical foundation of fuzzy logic, particularly loft designers, fuzzy set theory for modeling anchored in knowledge assessment. Special attention is given to including education and the universal design for learning model, which amplify personalization of the learning process. Empire data were collected using both traditional and adaptive assessment method, and express evaluation was conducted with specialists in education technologies. The proposed model evaluates knowledge based on the 5 key parameters: answer accurately, depth of understanding, logical consistently, task completion time, and independence of execution, as represented as a fuzzy set. The Mamdani inference method was applied for model implementation, and the centroid method was used for identification. This approach enables flexible, objective, and adaptive knowledge assessment in inclusive learning environments. Fuzzy model of assessing knowledge of education ethics in inclusive environmental. The develop of a mathematic model for knowledge assessment in an inclusive learning environmental in based on the application of fuzzy logic. Let us denote a set of input parameters considered in the elevation of learner's knowledge. More information you can see on screen. Next is the fuzzy model of assessing knowledge of education screens in an inclusive environmental. For each variable, we use a triangular of trapezoidal membership function, where ABC is a parameter that defines the boundaries of the category. And the next is the formalization of fuzzy rules. Let be sets of rules. You can see where A is a fuzzy set that define the level of input variables, and B is a fuzzy knowledge assessment. The aggregations of rules in perform using the Minkowski operator. The next is experiment result and discussion. Two input variables were defined: test score and class activity, along with the output variable final grade. For each variable, 3 fuzzy sets were assigned: low, medium, and high. Triangular and trapezoidal membership function are used. The membership functional and the graphics design surface illustrate how the knowledge assessment change depending of test score and students' activity. A teacher or an automated system can use this model for adaptive students' evaluation in an inclusive environmental. And fuzzy evaluation model. A cinematic model was built using the fuzzy logic toolbox in MATLAB Simulink. You can see our results of modeling, and after executing the MATLAB code, the following graph of membership fuzzing were obtained. It's figure 2 on screen. And each of the three supports in the graph corrected to a specific variable. Is a membership function graph for test code, is a B membership graph for class activity, and the C, maybe you can see, I can make something, and yes. And next one, the research confirmed the effectiveness of the proposed fuzzy logic-based knowledge assessed model is inclusive education setting. Employment in MATLAB simulating the model demonstrate high adaptivity and flexible during testing, during operating traditional testing method. Unlike rigging, dragging systems, the fuzzy model provides smooth transformation between grade levels. Simulators shows then students will be the same test score could recite different final grades. And conclusions. The study examines the problem of adaptive knowledge assessment in an inclusive learning environment and propose a fuzzy evaluation model that takes into account the individual characteristic of learner. The use of fuzzy logic allows of the consideration of uncertainty and incompleteness of input data, making the assessment process more fair and flexible. For example, for students, based on analytics and traditional assessment method, a mathematical model was developed in incorporating parameters such as testing results and students' activity during classes. The model was implemented in MATLAB simulating assessment process. The obtained results confirm the effectiveness of the proposed approach and demonstrate this potential for implementations model education managed information system and figure research prospect included expression and model by incoming iteration parameters, utilizing machine learning methods to optimize fuzzy logic rules and intelligent it with existing education platforms. And last but not least, actually for us, it's a future work. It's at all experiment model with more parameters, optimize rules using machine learning, and IntelliGaze with LMS education software. Thank you for your attention. Maybe you have a question.
Thank you. Yeah, Lyubov. Questions, please, colleagues. I have one question. Why did you choose fuzzy models for knowledge assessment? What is the fuzziness of the assessment or criteria assessment?
Thank you. We use this model because it's flexible for us. For result, our testing so work with student and is so popular maybe and so more because inclusive education is an important direction actually for us, and this system can analyze students' data and revise his ability to understand actually for us and use information.
Thank you. More questions, please.
I have one question. What shapes of fuzzy function you used in our work?
Thank you. Please, one moment, because bad connection. Can you repeat, please? Because really bad sound.
Questions: what shapes of fuzzy function you used? What types of fuzzy function? Can you see slides?
I'm sorry, bad connection.
Okay, thank you. Любовь.
But we can communication on email if you want, or more time, because I really have a problem with sound. And I listen only 1-2 words, and I don't understand.
Okay, thank you.
Thank you, really.
Thank you. Next presentation is CIS extent data analysis using statistical and supervised learning methods by Тетяна Говорущенко, Віталій Алексєйко, Віталій Левашенко, Юрій Войчеров, Дмитро Медзатий. Віталій, speaker, please. Віталій, welcome.
Good afternoon, dear colleagues. Can you see my screen?
Yes.
Okay, so let's start. My name is Vitaly Alexeyko, and I'm a PhD student. I'm pleased to present our paper titled CIS Extended Data Analysis using Statistical and Unsupervised Learning Methods. We represent Khmelnytskyi National University and University of Žilina, Slovakia. The authors of this study, Professor Tatiana Hovorushenko, Dean of the Faculty of Information Technologies, Doctor of Science, Professor Vitaly Levashenko, Department of Informatics, Vitaly Alexeyko, PhD student majoring in Information Systems and Technologies, Yuri Voichur, PhD, Senior Lecturer of Computer Engineering and Information Systems Department, and Dmytro Medzati, Candidate of Technical Sciences, Associate Professor. CIS extent in the Arctic and Antarctic is one of the 7 main climate indicators defined by the World Meteorological Organization. This indicator has a significant impact on the ecosystems of the Arctic and Antarctic regions, as well as on other regions of the globe, and plays a significant role in climate change. Determining the main trends and patterns of changes in sea ice extent is extremely relevant in the context of understanding potential risks not only for the polar regions, but also for the entire biosphere. Studying the time series of sea ice extent changes provides extremely valuable information for choosing techniques and models for predicting future indicators. To assess the fluctuations in sea ice extent, the data were aggregated by calculating monthly averages. It is clear from the chart that for the northern hemisphere, the minimum is observed in September and the maximum in March or sometimes in February. At the same time, for the southern hemisphere, the sea ice extent reaches its maximum values in September and its minimum values in February. A significant decrease in sea ice extent is observed in the northern hemisphere, especially in September and October. No such trends are recorded in the southern hemisphere. The slope is always positive and close to zero. Thus, there has been a gradual slight increase in sea ice extent. To examine regional trends by months, the time series data were decomposed into trends, seasonality, and residuals. This decomposition plays a key role as it helps to break down the underlying patterns and fluctuations in the data, as well as provide a clearer understanding of the process being analyzed. Trends are used to predict future values based on previous data, which is extremely important when predicting climate indicators based on historical data. Trends provide insight into future developments, allowing governments and organizations to plan and develop adaptation and mitigation strategies. Thus, if the trend indicates a rise in sea level due to melting ice, cities can prepare for potential flooding or inundation. Residuals analysis allows us to assess how well the model has captured the data. If the residuals show patterns, for example, autocorrelation, this indicates that the model may need adjustment or additional features. If the residuals are large at a particular time, this may indicate an anomaly or event that was not captured by a trend or seasonal patterns. For example, a sudden spike in sea ice extent due to extreme weather would be considered a residual anomaly. If the residuals show consistent patterns, the model may need to be refined to make more accurate predictions. A figure on the screen shows the decomposition of the time series into the main components, trend seasonality and residuals for September in the North Hemisphere when annually a minimum of sea ice extent are observed. Random values of residuals indicating that the decomposition has successfully isolated trend and seasonality. The Dickey-Fuller test is a statistical test that is used to determine the stationarity of a time series by testing the null hypothesis of the presence of a unit root is an autoregressive time series model. Null hypothesis can be described as the series has a unit root and is non-stationary. And alternative hypothesis, the series does not have a unit root and is stationary. Results of Dickey-Fuller test are presented in table on the screen. For Northern Hemisphere, the test statistic is greater than all critical values, and the p-value is much greater than the typical significance level. As a result, it is failed to reject the null hypothesis that the time series has a unit root. Thus, the time series for North Hemisphere sea ice extent is non-stationary. It means that its statistical properties, mean, variance, autocorrelation, may change over time. Therefore, might be necessary to provide further transformation, for example, differencing, to make time series stationary before forecasting. For Southern Hemisphere, the test statistic is less than the critical value at the 1% significance level, and the p-value is less than 0.05. Thus, the null hypothesis is rejected. Therefore, time series has a unit root. It means that the time series for South Hemisphere sea ice extent is stationary. Thus, its statistical properties do not change over time. For better understanding patterns and detect anomalies in data, it was performed clustering analysis using unsupervised learning techniques. The results of Cummins clustering for the North Hemisphere shows three distinct clusters. Cluster 0, highlighted in blue, demonstrates high values of sea ice extent from 12 to 16 million square kilometers. This value were dominant before 2000s. Cluster 1, highlighted in green, covers values between 6 and 11 million square kilometers. This cluster is intermediate and it indicates a gradual transition from high to lower extents. Cluster 2, highlighted in orange, indicates low values of sea ice extent. They become dominant after the early 2000s. The transition from cluster 0 to 1 and then to 2 shows a steady decline in sea ice extent over time. In Southern Hemisphere, Cummins clustering results show us different patterns compared to the North Hemisphere. There are also three distinct clusters. Cluster 0, highlighted in blue, demonstrates low sea ice extent. It was dominant Cluster 1, highlighted in orange, shows intermediate values which become dominant after 2000s when cluster 0 was dominant in early time. Cluster second, highlighted in green, represents high values mostly before the 21st century, then declining over time. Unlike the Arctic, where observed tendencies to losing ice, situation in the Antarctic is more stable. In some periods, trends are slightly increasing. The transition from cluster 2 to 1 suggests seasonal fluctuations, but not a clear long-term decline like in the north. The clustering suggests that sea ice extent fluctuations in the south hemisphere are more complex and may have more hidden patterns. The clustering performed using the DB-scan method did not yield significant results. The method did not recognize differences, assigning L values to one cluster for north and south hemispheres. This result indicates that no anomalous values were detected in the values of both hemispheres. Hierarchical clustering for North Hemisphere detects three clusters. There are low values in cluster 0, highlighted in blue. It represents months with low values of sea ice extent among all years. Cluster 1 represents intermediate values. As for months with the highest extent in each year, it is detected a decreasing tendency. Cluster 2, highlighted in green, demonstrates high values of sea ice extent up to the beginning 1990s. Transition from cluster 2 to 1 shows the main trend to decreasing the highest sea ice extent each year. The results of hierarchical clustering for South Hemisphere are presented in figure. It is detected three clusters. Cluster 0, highlighted in blue, shows low values, which demonstrates months with yearly minimum sea ice extent. Cluster 1, highlighted in orange, represent values with high amplitude, which mostly were observed after middle of 1990s. Cluster 2 demonstrates values with lower amplitude in earlier years. Transition from cluster 2 to 1 shows increasing of amplitude and difference between months with high values of sea ice extent. Maximum values are increasing and intermediate values are decreasing. Thus, South Hemisphere has more complex patterns compared to North. Comprehensive statistical analysis of time series allows to identify the main trends of change in indicators over time. Principal component decomposition as trends, seasonality residuals allows to identify the main seasonal fluctuations and potential anomalies in the data. Checking the data for stationary using the Dickey-Fuller test provides information on the need for further data analysis in preparation for forecasting. The study analyzes fluctuations in sea ice extent by identifying monthly trends and identifies the main problem in the Arctic and Antarctic regions. The calculation provides a basis for further research for forecasting of sea ice extent. Results of the clustering analysis shows rapidly changes in sea ice extent in North Hemisphere. Thus, Arctic region is vulnerable to climate change and needs urgent climate actions. Sea ice extent in South Hemisphere demonstrate more stable situation. It is needed more long-term observation and more complex analysis to determine hidden patterns in Antarctic sea ice extent. Thank you for attention. Maybe you have some questions.
Thank you, Tali. Questions, please, colleagues?
May I please?
Yes,
please.
Thank you for the interesting presentation and for the great work that is done to complete this paper. And could you please tell which drawbacks or which limitations do you see in your system? Because there are always some limitations. Did you think of it?
Okay, I understand the question. Thank you. Of course, this approach use unsupervised learning, and it has some weakness. But now for data analysis, they are not so significant as it can be in future, where it was provided some forecasting or for some systems to predict future values. What about limitations? It can be, for example, in clustering, actually not good recognition, not good recognition some patterns, I mean, and provides data to some clusters, another clusters as it is actually, but I think it's not so significant in this research. So
Thank you so much for your answer.
thank you. More questions, please? No more questions. Next presentation is automatic bilateral filtering of digital X-ray rocking curves using histograms by Sergei Balosyak, Igor Fachuk, Zheng Binhu, Inna Yakovleva, and Sergei Yakovlev. Who is speaker?
I'm speaker Sergei Yakovlev.
Welcome, Sergei.
Can I share my screen? Do you see my screen?
Yes.
Good morning, colleagues. The topic of the paper is automatic bilateral filtering of digital X-ray rocking curves using histogram. Okay, it is the contents of the article, presentation, and motivation and state of the art. Experimental X-ray rocking curves are widely used to study the structure of various materials, in our case, crystal. Analysis of the angular distribution of such curves allows us to obtain information about the structural perfection of the studied sample. As you can see on the figure, a bundle of X-rays falls on the crystal under study. The crystal rotates at specific angles omega, and for each rotation angle omega, the detector measures the intensity of X-rays reflected from the crystal. The analysis of X-ray curves is complicated by the presence of significant noise level. One of the most effective is the bilateral filtering algorithm. However, a certain complexity of the application of bilateral filtering lies in the selection of filter parameters. And the object of the research. In this research, we propose to determine the parameters of the bilateral filter automatically taking into account the noise level on the X-ray curve. To determine the noise level, the high frequency component of the signal is calculated by the Laplace filter, and the histogram of the obtained high frequency component is analyzed. Automatic bilateral filtering allows processing of series curves obtained on an X-ray diffractometer with high accuracy and speed. As can see on in the figure, the initial curve with noise left figure transformed to filtered curve without noise by way of bilateral filtering on the right figure. Let's look at method of bilateral filtering of X-ray curves. Bilateral filtering consists in convolution of the initial curve LH with the filter kernel VB by formula 1. Where LH B is a curve after filtering, the kernel VB of the bilateral filter is described by the formula 2. Sigma BS is the standard deviation of the kernel in the angular domain. Sigma BI is the standard deviation of the kernel in the intensity domain. The bilateral filter is a combination of two Gaussian filters. One filter performs processing in the spatial domain, and the other filter performs processing in the intensity. The SD sigma BI of the kernel in the intensity domain is calculated by 3 sigma rule using the formula. The high frequency component is extracted by convolution of the initial curve LH with Laplace filter WL using the formula 4. Next slide.
Smooth histograms H and F calculates based on the high frequency component, as you can see on the slide. The central peak of the histogram is extracted using the threshold H and F that calculated using the formula phi, where the H and F max is the maximum value of the histogram. The histogram above the threshold describes the Gaussian distribution. The left boundary large BNA left boundary and the right boundary of the histogram peak are determined by the intersection of the Gaussian distribution with the threshold, vertical and horizontal. For the histogram peak, its SD sigma H all is calculated. The exact value of SD sigma H on the histogram peak is calculated by formula 6. And the noise level sigma n is calculated based on such values of the high frequency component by the formula 7. The obtained value of the noise level is used to calculate the SD sigma bi of the filter kernel. The value SD sigma bs of the bilateral filter kernel in the angular domain is determined based on the given value of coefficient time. Next slide. The software of bilateral filtering of X-ray cores is implemented in Python based on the developed mathematical model. Bilateral filtering involves the following stage: reading the initial curve from file, calculating the high frequency component of the signal. Next, calculating the histogram HN of the high frequency component. Next, calculating the smooth histogram, selection of the central peak of the histogram, calculation of the SD sigma of the histogram peak, calculation of the noise level sigma n based on the high frequency component, calculation of the SD sigma bi of the kernel in the intensity domain, determination of the SD sigma bs of the kernel in the angular domain, and the calculation for each point of the X-ray curve of the bilateral filter kernel will be performing bilateral filtering. Results of bilateral filtering of X-ray. On figure 4, you can see initial X-ray curve. On figure 5, values of the, you can see values of the high frequency component calculated for the initial X-ray curve. For better visualization, the value of high frequency component is limited in the range from minus 100 to plus 100. On the figure 6, you can see smoothed histogram H and F for the noise component. On figure 7, you can see the value of the high frequency component with a permission interval for noise. Next. On figure 8, you can see X-ray curve after bilateral filtering, which calculated on the basis of the initial curve. On figure 9, you can see initial X-ray curve and X-ray curve LHB after bilateral filtering. Match initial and result with calculation. The figures show that after filter filtering, the noise level has significantly decreased, while the shape of the peaks has been preserved. And conclusion. Software has been developed for noise removal of on digital X-ray curves using a bilateral filter whose parameters are determined automatically. A mathematical model has been developed for calculating the noise level sigma n on the initial X-ray curve and the parameters of the bilateral filter. The following filter parameters were used: the standard deviation sigma bi of the kernel in the intensity domain and the standard deviation sigma bs in the angular domain. The high frequency component of the X-ray curve has been extracted by a Laplace filter. The histogram of the high frequency component has been calculated, and permissible interval for noise values on the high frequency component has been set. The software for automatic bilateral filtering of X-ray curves has been developed in the Python. The novelty of the work is a calculation of the noise level sigma n based on the high frequency component of the X-ray curve, taking into account its histogram. Bilateral filtering of 10 experimental X-ray curves of the test dataset has been performed. It has been shown the bilateral filtering of X-ray curves allows not only to significantly reduce the noise level, but also to preserve the shape of the useful signal. Thanks for your attention.
Thank you, dear Sergey. Questions, please, dear colleagues? What practical implementation of your research?
Thank you for the
which
question.
sphere, maybe?
Yes, our colleagues are analyzing crystals. In our case, it was cadmium tellur, and using the proof of this crystal on the special tools with X-ray pulse, and by the result, by this curve, it's the main parameter for analyze is this crystal good or bad, and the quality of the crystal. And after the tool is analyzing tool is not perfect, of course, and it needs some filtering for better result. It can be implemented for testing and for get more quality curve of the crystal, the analyzing materials.
Thank you. More questions, please? No more questions. Thank you, dear Sergey.
Thank you.
Next presentation is iterative fuzzy prototype conceptualization of multifactorial constrained prior data spaces for intelligent decision systems by Serge Dolgih, Oksana Mulesa, and Volodymyr Zabadosh. I will share video.
Hi everyone. We begin with a problem common in AI, learning in a situation where we have little or no prior knowledge about the data. This is known as learning with constrained prior. In such cases, traditional supervised learning methods are not effective. To address this, we turn to methods like self-supervised, fuzzy logic, and prototype modeling. The goal here is to develop decision-making models that become more accurate over time, even if we start with very limited knowledge. We explore fuzzy prototype analysis, a method designed for exactly situations where we lack prior knowledge about the data distribution. Unlike traditional models that classify data into fixed categories, fuzzy prototype analysis allows for probabilistic association. This means a single data point can belong to multiple prototype classes with different confidence levels, and the sum of the membership degrees for each point across all prototypes must equal 1. We can see in the figure the data point x1 is associated with 3 prototypes. The membership degrees for x1 indicate that it belongs most strongly to prototype px3 with membership 0.44, followed by P2 and leads to px1 with only 0.05. It also was to say the model precision is characterized by a confidence threshold indicating how confident the model is when associating an observation X to specific prototype. Let's walk through the iteration step of fuzzy prototype analysis. So firstly, we collect and prepare the data. Data can be unlabeled, high dimensional, and may have an unknown structure. The goal here is to have a representative sample. Next, we build an embedding space. This could be done by applying methods like PCA or autoencoder. Further, by applying k-means clustering or other techniques, we define a set of prototypes. The next step, we calculate the degree of membership, which indicates how much the point belongs to each prototype. When it comes to the decision making, we have 2 options. If the membership degree exceeded an expected threshold, then we consequently classify the point into certain prototypes. So here we have a clarity. For less certain cases, we can use fuzzy decision model where the final decision is a weighted sum of the decisions for all prototypes. Based on the confusion matrix, we can calculate model accuracy. Lastly, we expand the sample set and repeat the process with new data. To illustrate the fuzzy prototype method, we use a data set of images of basic geometric shapes. The images in the data set were of 3 basic types: cycles, triangles, and backgrounds, of variable size and grayscale contrast. The resolution of the image was 64 by 64 pixels. That means that each data point corresponding to a single observation that have more than 4,000 numerical factors in the range between 0 and 1. To examine the relationship between the precision of the fuzzy prototype model on size of sampling, we used samples of 3 different types. The first having 30 images per type, second 50 images per type, and third has 100 images per type. The performance of fuzzy prototype models is evaluated based on precision and resolution characteristics. Accuracy is calculated as sum of correct prediction divided by the total number of classes. Confusion is calculated as the sum of incorrect predictions divided by the total number of class combinations. As the first step, informative dimensionality reduction was applied to other image data set using a generative neural network with a convolutional encoder. As shown in figure, the data is mapped to lower dimensional space, which help us better understand the distribution of data without needing extensive labeled samples. In this slide, we present the results from fuzzy prototype model using confusion matrix and precision matrix. Table 1 shows the confusion matrix for second image data set with the confidence threshold that equal 0.95. It illustrates how the model classifies three types of shapes: cycles, triangles, and backgrounds in two classes. For instance, the cycle is perfectly classified into cluster 0, while the triangle and background shows partial membership across classes. Table 2 displays the precision and resolution of the model across different sample sizes. It provides the accuracy and confusion metrics for two confidence thresholds, 0.8 and 0.9. As the sample size increases, we can see that both the precision and accuracy improve, proving the effectiveness of larger data sets in refining the fuzzy prototype model. This demonstrates how iterative learning with larger samples enhances the model ability to make accurate decisions. To sum up, this study introduced a method for learning with constrained prior data, combining unsupervised learning, generative models, and fuzzy clustering. The approach allows intelligent systems to learn complex data spaces with minimal data, improving decision-making over time. While adaptable to various problem types, future work will focus on verifying the learning process and its effectiveness. Additionally, we aim to explore hybrid decisions for uncertain cases and apply this method to real-world systems in constrained environments. Thank you for listening to this presentation. We are open to your questions.
Thank you. Questions, please, to Volodymyr, colleagues. Colleagues, questions? I have one small question about practical implementation of your approach.
Yeah, so do you hear me well?
Yes, yes.
Hi all. Yeah, so the practical. So we are proposing like a concept, right? That can be this concept can be used to in real world application. Like we based on this concept, we can implement this in medicine, where we faced with unlabeled data, right? And the system can start with like little samples, and while data accumulated, then it will improve over time. So yeah, particularly in medicine and the other close areas that we face with such kind of problems prior data limitation, right? So
Thank you. More questions, colleagues? No more questions. Okay, thank you. Next presentation is predictive autoscaling in AWS serverless by means of machine learning and SQS metrics by Alexander Kirichenko, Sergey Ostapov, and Oksana Kirichenko. Who is speaker?
Yeah, I am Alexander Kirichenko. Yeah, let me go screen. Wait a minute, please. I hope you can see it.
Yes, we see.
Yeah, thank you very much. So my name is Alexander Kirichenko. Hello, everyone. I'll be presenting our research made with my colleagues on predictive autoscaling in AWS serverless using machine learning and SQS metrics. And what we'll cover today, we will talk about why autoscaling in serverless is challenging, what problem we are solving, and how we'll build our ML-based predictive autoscaler. Also, what type of performance improvements and key findings we got, and also we discuss next steps and recommendation. So nowadays, serverless is popular concept of development of application in cloud environments. The main idea behind of this is that we delegate all of stuff to cloud provider. I mean, all infrastructure tasks, and we concentrate on code writing. What does it mean for us as full developers? We build our business logic, and everything else is the responsibility of cloud provider. I mean, provisioning, security, running our application, and so on. And in this case, as a cloud provider makes decision when our application should be scaled up or down. So how it can be done? Here on the slide, you can see the main auto-scaling strategies. First strategy is reactive auto-scaling. We adjust capacity based on real-time demand and scaling up or down our application in response of incoming traffic. Second point, this is warm pool. Warm pool, we just prepare some pre-initialized instances that can be quickly launched, and they can process incoming requests. And in this way, we just reduce startup delays. And third one, we can create, this is kind of proactive resource creation. We can provision resources in anticipation of demand, ensuring faster response time in some cases. It's definitely that this approach has certain limitations. First of all, first limitation, this is cold starts. It usually takes some time to create and spin up some additional resources to make them ready to handle all incoming requests. Second point is cost efficiency. Keeping resources up, like they're running every time and waiting for our request, costs some money. And in serverless, we as a user pay only what we really utilize. Everything else, cloud provider will pay for everything else, and it's not kind of cost efficient for cloud provider to keep all resources for us in ready state. What was our goal? Our goal was to develop a ready-to-use solution that allows us to solve at least part of this problem. In this slide, you can see an architecture diagram of simple distributed application to process some data in parallel. This is really in real life. This is application will look more complex. For study purposes, we simplified it as much as possible. The core component of such application is this queue. And the queue allows us to decouple processing components, and as a result, we can scale them up and down separately. To track workload in our system, we can use some of metric collected for SQS during some period of time. First metric is the approximate number of messages visible. In simple words, this is just length of queue. Second metric, very self-descriptive, number of messages sent. Both of them are a really good indicator to predict system behavior in the near future. Here's the architecture of our framework. It consists of several components. On the slide, you can see all of them. Event bridge, this is our scheduler, which create on some schedule some events for our system. Second one is the CloudWatch. It collects our metrics. SageMaker, this is a fully managed service that allows us build, train, deploy machine learning models in quick and efficient way. This is a very good one. And also we have AWS Lambda that fetches and predicted workload from the deployed model and adjust some settings in our system. On this slide, we describe, this is DPR. This is some component from SageMaker. DPR, this is supervised machine learning algorithm, because I should notice that SageMaker contains a lot of different algorithms. This is one of them that is really good one for time series prediction and forecasting. And it uses recurrent neural networks underhood to produce probabilistic forecasts. it definitely has its own advantages and disadvantages. From our perspective, critical ones are ability to handle missing data and also train model on multiple related time series data. On this slide, you can see we describe all steps that should be taken to adjust lambda provision concurrency. Provision concurrency in this case means the maximum number of lambda instances that can run simultaneously to process incoming data. What this algorithm does, it just takes predicted values and calculate desired number of instances based on predicted values and threshold values limited by a count quote. Sorry. To test our solution, we emulated high load by means of locust. This is locus, sorry. This is distributed load testing tool, very useful, and that allows us to simulate thousands of user to test system behavior under heavy traffic. On diagrams, you can find some spikes and some dynamic of data ingestion and egress during time testing process. And next diagram demonstrate forecasting with confidence intervals for prediction in both chosen metrics. Here you can see multiple spikes in our real data to see how predicted autoscaling handle this data. And what we've done here, we predict how much data coming into our system in the next 50 minutes, and also we can judge about quality of predicted data. So, result and discussion. It's worth to notice that we conducted experiments using real SQS data and compared default AWS autoscaling with our own machine learning-based predicted autoscaling. And the primary outcome here is that we managed to reduce call stars till 27%. And also, we can reduce number of unprocessed requests till 14%. This is maybe main important outcomes. Also, despite of the set advantages, our approach has some challenges. DPR requires a significant amount of historical data to make forecasting more accurate. Also, it requires regular retraining, like we collect historical data for some period of time, and time to time we need to rebuild our model. And this is a very expensive operation. And choosing right parameter to train a DPR model is still a challenge. So what we gonna improve in our framework? We need to improve the quality of forecasting models. Also, we have to find the optimal values of hyperparameters to train DPR model. Besides this, we can use additional metrics for better prediction. By default, out of the box, SQS expose a set of different metrics that completely describe its work in a real environment. And we can collect and combine several of them just to find the best combination to make our prediction more reliable and more accurate. Also, we can implement AWS pipelines for continuous model learning. So we can automate our work, and this allows us not to not to apply some manual work to keep our system in good shape. In the result, we created a framework for predictive automating autoscaling for computer resourcing. Also, we built models that shows good enough results. It allows reduced number of call starts. Also, we still have the main limitation of proposed frameworks. This is lack of historical data. And the main outcomes that we have production-ready solutions that can be a part of any serverless application to handle situation when we use queue as a primary component of such a system. So it seems that's all. Thank you for your attention, and any questions?
Thank you. Questions, please, dear colleagues? Dear colleagues, questions? No questions. Thank you, dear Alexander. And the next presentation is model of the hierarchy of quality factor criteria layout processes by Zarina Selmenska, Zorislava Plachtina, Miroslava Dubnevich, and Orest Hamula. Who is speaker?
Hello, my name is Zorislava Plachtina, and today I will be speaker. Let me share the screen. One sec, I'm so sorry. Where is this? Oh, yeah. Okay. Can you see my presentation?
Yes, yes.
So good morning and welcome to my presentation. My name is Zorislava Plachtina and I am a PhD student at Lviv Polytechnic National University, IPMT, Ukraine, Lviv. The topic of my presentation is the model of the hierarchy of quality factor criteria layout process. I divided my presentation into three main parts. First of all, I'll talk about the motivation for this research. Second, we will look at the research process. And finally, I'll tell you about the result. So let's get started. I'd like to begin by showing you how factors such as thematic planning, reader preferences, publication type, font design, illustration, integration, amongst other things, affect the quality of the layout. Each factor contributes uniquely to the final product, yet their interrelationship are often overlooked or undervalued. This study seeks to unravel this complexity by identifying and analyzing the factors that shape layout quality. By representing this relationship through semantic networks and oriented graphs, this search aims to provide a structured framework for understanding how individual elements influence one another and collectively impact the finished publication. Now let's move on to my next topic, which is the research process. In this research, we focus on the criteria that have an obvious impact on the layout process, such as thematic and production planning, reader demand, type of publication, volume of publication, size parameters of publication, font design, illustrative design, layout complexity group, text composition rules, and page completion rules. In the next phase, the set of criteria for the process and the possible interaction between them are presented in the form of an oriented graph, which we can see on the screen. Based on this graph, we have built a binary dependency matrix for a set of vertices by using the following rule. 1, if criteria I depends on criteria J, and 0 if not. Afterwards, we build the binary reachability matrix B. To determine hierarchical levels, we use the matrix of reachability and dependence of subsets, on the basis of which we build iterative tables, the initial one being the lowest in terms of priority of influence on the process under research. As you can see from the table, the second column is the number of the unique elements of the corresponding rows of the reachability metrics, and the third column is the numbers of the unit elements of the columns of this matrix. The fourth column indicates the numbers of the unit elements common to the second and third columns, the so-called intersection of sets. According to the algorithm for building hierarchies, we deleted rows 2 and 9 from the table, and in the second and the third columns of the table, we deleted the numbers 2 and 9. In the second iteration, the equality is performed for the factors with number 1. It determines the next level of the hierarchy. We deleted row 1 from table and the same numbers in the second and third columns. As a result, we have got the following table. Performing in the same steps as the previous one, we will get the data for the next iteration. Thus, as a result of performing actions on the elements of the initial graphs, we have oriented a hierarchically structured model that simulates the priority of the influence of selected factors on the quality of layout. The last factor analyzed is the first in terms of priority of influence on the layout process. As you can see on this chart, the layout and font design are of the greatest importance, depending on which a hierarchical pyramid of action and statement factors is built. The next level is formed by the factors completion rules, layout complexity group, and illustration design. And then separate levels are formed by the factors size parameters of the publication, volume of a publication, type of publication, and thematic and production planning. Reader demand, the text and text composition rules determine the lowest level of the hierarchy. This research identified crucial factors affecting layout quality. A semantic network was used, a formalized relationship between these factors, utilizing a binary matrix and iterative tables to create a hierarchical model. Font design and layout emerged as the most influential criteria, followed by completion rules and illustration design. The proposed model can become an effective tool for primary control for and management of the layout process at all its stages, ensuring the highest quality of the finished publication. Thank you for your attention. If you have any question, I'll be happy to answer them.
Thank you, dear Zarislava. Questions, dear colleagues? Colleagues, questions? No questions, thank you. Then a last presentation for this subsection is Information Diagnostic Online Smart Platform, utilizing an open source virtual learning environment by Tatiana Govorushenko, Artem Boyarchuk, Olga Pavlova, Sergey Lysenko, and Mariusz Mazurkiewicz. Olga is speaker. Welcome, Olga.
Dear colleagues, can you see my screen?
Yes, yes.
In the full presentation mode, yeah?
Yes.
Great. Then we start, dear colleagues, let me introduce the Information Diagnostic Online Smart Platform based on the adaptation of an open source virtual learning environment. The project that my colleagues Tatiana Govorushenko, Sergey Lysenko, Artem Boyarchuk, Mariusz Mazurkiewicz, and I have been working on in the framework of Erasmus Plus project. From the end of 2022, Khmelnytsky National University team is a member of Erasmus Plus Smart PL project, personalized model of student learning based on the virtual learning environment of intelligent tutoring, learning without limits, or Smart PL. This research is conducted in the framework of Smart PL project and co-founded by the Erasmus Plus program of the European Union. Feedback is a key aspect of the development of any learning platform. Information and diagnostic online platforms allow the individualized learning. They provide the opportunity to assess the level of learning, adaptation to the individual needs of users, ensure the effectiveness of the learning process. The feedback gives the opportunity to take the results of the students and give them the maybe support and provide the advice on the further learning in this platform or in another ones. At the beginning of the project, a working group of Khmelnytsky National University conducted a survey among the university academic society, students, and academic staff on practice of implementing the individualized approach for studying at the university. One of the questions given to students was, do you consider that your university applies a personalized approach for tasks and test compilation? The results of the survey are given on the slide. Thus, 46.4% of respondents say no, almost 30% say yes, and 23.6% say that it is difficult for them to answer. Since the students and are the main stakeholders in the educational process, it is relevant to find out their personalized needs to be able to adjust the educational content and materials for them. Therefore, there is a need in development of the information diagnostic online smart platform that will contain different tests to learn students' skills levels. The methodology that has been taken into account during the development of this platform is blended learning. That is a combination of instructor-led learning and digital or self-guided learning. The development process of such system, in the development process, we used the inclusive approach that is presented on this slide, and the approach of intercultural understanding, since this is an international project and we are expecting international students to take part in the project and take the test. The intercultural understanding approach includes recognizing culture and developing respect, interacting and empathizing with others, and reflecting on intercultural experiences and taking responsibility. Therefore, the proposed and the developed during this research system is designed according to the principles of diversity, equity, and inclusion. Here we can see the architecture of the developed system. We have three roles for the users. The first role is unregistered user or guest that can register in the system or just see the main screen, the main dashboard of the system. For the registered users, we have two roles. The first one is student. The second one is educator or expert. The students can pass diagnostic tests, choose educational content according to the personal needs, view performance analysis, view the system's recommendation for the educational materials, set personal educational goals, track the progress towards already set goals by passing the tests several times, and so on. For the educators or experts, we have the following roles, such as create courses, create the course content, edit courses, provide feedback to the administrator, facilitate discussion on the discussion forum. For example, if the students have questions or some problems to solve, and provide tutorials, frequently asked questions, answers, and resources for students, self-help, and troubleshooting common issues. And the third role is for the administrator or support staff. It includes smart platform management. The administrator can create course template with intuitive design, manage user access permissions, provide feedbacks for educators and students, manage discussion forum, provide assistance for educators and students, and provide frequently asked questions on platform using for educators and for students. Here we can see the platform itself. It is designed using the Moodle platform as a basic and adapted and is adapted to the needs and requirements of the project. Here is the first or main page. We can see the registration form and the login form for the students who are already registered. Then after signing in and logging in, we can see the list of courses that are available in the platform. The student can enter the course, and after that, the courses that student was enrolled to appear on their personal page. So the student can see the list of the courses, their description, and the student can pass the courses several times after getting feedback. And if the student wants to increase like the knowledge, to improve the knowledge on a specific subject, the courses are still available in the platform. And in each course, we have a list of tests. So the student can pass the tests and get the results on each competence that are given on this slide. And as a conclusion, we can say that in the case of this study, user requirements, permissions, and system architecture for the information diagnostic online smart platform based on the adaptation of an open source virtual learning environment were developed. This platform is proposed to provide a comprehensive, flexible, and adaptive learning environment that caters to the diverse needs of the students in higher education. I can say that the experiment is still ongoing. Students are enrolling in the system. It is working, and the students are passing the tests, are getting their results and feedback. And we will be able to make a full conclusion on the work of the system in the framework of this project as soon as the students will pass the test several times and will get their improved results and new feedback on the increased knowledge. So in the conclusion of this work, we can say that the information diagnostic online smart platform represents a forward-thinking solution that aligns with the principles of personalized learning. It not only enhances the educational experience for students, but also supports educators in delivering high-quality, tailored instructions for the students. Thank you for your attention. If there are some questions, I will be happy to answer them. Thank you.
Thank you, dear Olga. Colleagues, questions, please.
A small question. Is this some customization of Moodle, or is it completely your new approach for this? Because I heard that you mentioned about Moodle, you have some you use some features of Moodle, right?
Yes, it is correct. Actually, we had a new author delivered approach in the basis of this project. However, we were free to choose the platform to deliver it, to implement it. We chose Moodle-based platform. The Moodle is just the driving engine in this platform because it has intuitive design. It is simple to use. It is simple to manage. And since we are working with international students, with students from different universities, different countries, our task was to develop the platform that will be easy to understand, to learn how to use it for students and for the teachers, for facilitators. That's why Moodle was chosen as a driving engine for this platform. But the approach that was taken into account and that was that we aimed to deliver using this platform was completely developed by the group of authors of this research and by the working group of this Smart PL Erasmus Plus project.
Okay, so it was just a prototype, yeah, and
Yes.
you implement your own system with some
Using this ready-made prototype, yes.
Yeah, thank you very much. Great work. Thank you for
Thank you for the question.
Thank you. More questions, colleagues? No more questions. Thank you, dear Olga. Dear colleagues, we completed our subsection faster than we had planned, and now we have a coffee break. So we will meet at 11:45 to continue our section session, and see you. Coffee break till 11:45.
See you.
See you. Dear colleagues, let's start our second part of to welcome at the second part of Intelligent Information Technologies section of IntelITSIS 2025 workshop. My name is Olga Pavlova. I will be moderating this section. And I would like to remind about the timing of the presentation. 10 minutes is for the presentation and up to 5 minutes is for the questions and answers section. And we have in our section the following presenters. The first presentation is by Andrei Shupta, Alexander Barmak, Pavlo Radyuk, and Yuri Krak. Feature computation, procedure for fake news detection, and LLM-based extraction approach. Do we have a presenter here among us?
Yes. Hello, everyone. Do you hear me well?
Yes, perfect.
Great. So I will start and share my screen.
Please.
Okay. Now, do you see presentation?
Yes, we do. In a full screen mode. Thank you.
Great. Awesome. Yes, so hello everyone, great to be here, and I'm here to present our research on novel approach about feature computation procedure for fake news detection and LLM-based extraction approach. This is combined efforts from Khmelnytskyi National University, Taras Shevchenko National University, and Glushkov Cybernetics Institute. So today in presentation, I will talk about background, about problem statement, what we propose, how our experiments and results went, and we can talk about conclusion and have some questions. So everybody knows about fake news, that it's a lot of problems comes from fake news in global, in different areas. Every year, social media grows, and all these problems affect not only like social media, but other sections and areas like healthcare, politics, and other sections. And fake news usually spreads even quicker than like real news, and with recent technologies like ChatGPT, information even harder to detect what is fake news and what is not, and a lot of information has been generated. There are different approaches that has been already by all of these years, like machine learning and NLP methods like SVM, TD, IDF, but they have their own problems, like they hardly understand context and mimicry. Then we had deep learning models like SNN and LSTM, but they still, even though with bigger contextual information, they didn't understand context. And other methods like static embeddings, like word-to-vector. After that, we have begun like era of transformers and LLMs models. For example, BERT is one of those, and for LLM we can talk about GPT, Llama, and other. But still there is an explainability gap because those models and in general transformers and LLMs act like black boxes. So there are need for explainable methods that will show us human understandable cues, and also there are already like areas where explainable AI develops with methods like LIME and SHARP, but we also need like improved methods because they have their own downsides. So yeah, to describe in general background, as I said, different areas has different pluses and minuses, and we need to have our approaches improved because of explainability that we lack with like a lot of information, and methods like Lyman Shop doesn't cover everything that we want from fake news detection. There are, like, to specify several key challenges for fake news detection is that mimicking credible sources and making mimicking sources and making after-generated content makes detection a lot harder for models like and transformers and machine learning, because they lack context, and every day fake news evolves, and it's hard to keep up with fake news generation with current methods of fake news detection. Method that we propose looks like this in general. We have raw text that we have on the left. We generated synthesized characteristics to identify suspicious cues of the text. These cues are then transformed in some numerical representations via our feature computation procedure. Then we combine this computation procedure with LLM embeddings, and we do additional machine learning model for classification. Finally, in the end, the expert conclusion will be more text-based, transparent, and explainable, with some type of verdict that could be explainable for human. To implement this procedure, we have decomposed our implementation in 4 tasks. First task is synthesize characteristics. Second is formulate feature computation procedure, how we do it. Then we build ML model to combine these features with embeddings, and then we construct expert conclusion. Yes, so for feature computation procedure, we have this scheme where we have input data. We identified characteristics feature, and step by step we gather metadata, define formula for each feature, implement both forward and inverse procedures for detecting this feature, incorporate logical operations, because some feature can depend on each other, and we produce final feature set. On the screen you can see example of, for example, we have similar sentences. Our simple calculation will be detect with NLP these similar sentences and get our general, for example, score for how similar this text is compared to itself. Then for building machine learning method, we have our input vector. We have our input vector, and from task we take embeddings from LLM and BERT and combine them. The classifiers that we train will be built, I will show you later, with regression, and also, yeah, I will show you on next slide. And in the final step, we construct expert conclusion from our templates, classifier predictors. We identified features for this prediction and retrieved corresponding evidence. And for example, some explanation could be as you see on the screen, verdict fake, explainable rational, and why we think so. so like expert can understand what we and where we found that this news is fake. So for datasets, we have picked like Ukrainian and English news available on the internet. We split and did standard like 80% train, 10 validation, 10% testing. And for pre-processing, we did some kind of normalization and retaining domain terms. We picked for baseline for text embeddings, like for different levels for TD, TF, IDF, word to vector, BERT, and LLM. By our examples and like discovery, we picked a few features that we tried to analyze. It was like paraphrase ratio, how subjective text is, sentiment of the text, what language is used, if it's like usual or inappropriate, and fact confirmation that we can check like from LLM itself or with third-party API. Classifier, as I said before, is a two-layer fit-for natural networked, and it has been trained with binary cross-entropy loss. And to evaluate, we have used standard metrics like accuracy, precision, recall, F1. There are some examples that we want to show, and here for English dataset, we have for each baseline, and like during testing and on specific data sets, we have like higher results with like different approaches. And for Ukrainian, also similar results that we, with LLM plus our like extension and classificator, we have better accuracy. This is visualization for English and Ukrainian dataset. Also, we did a ROC curve and checked how our precision recall works with datasets. And on the left and right, we like compared, for example, BERT without our approach and BERT with our approach. And as we can see, we have better result and performance using proposed approach. There are, of course, limitations, but let's first like discuss pluses. Improved accuracy, enhanced interpretability, adaptability, and synergy. This helps us to adapt to like different kind of fake news more quickly. Like this will be part of future development, but we aim to make this system automatic and automatically detect new features. But from limitation, currently it's computational cost. If we would use LLM, it resource intensive, and if we use some API, it costs money. And we depend on this feature, on this LLM tools. Another that limitation is, as I said, feature definition, because some features that we detect manually could not be the best fit for some or for one part of fake news, but could be good detection for another part of fake news. And currently no dynamic adaptation. We did only statical like features. Conclusion. So in summary, we introduced this method and formulated how it works. It so we discussed how we can improve fake news detection, how we can increase with LLM and extraction and own classifier accuracy and precision of fake news detection. And the most important part is to implement explainability and to have some transparency in the end. So our people who use this system won't only get some unknown result, true or false, but also will get explanation and where we detected places that looked like fake to us. Yeah, in future, we think that we can make the system like more reliable. We can make it dynamically extract some automatic feature at the start, and yeah, there are a lot of areas for improvements that we can talk if you have questions.
Thank you so much for the presentation, dear colleagues. Do you have any questions to the presenter?
Yes, I have a question.
Please.
Can you show an example of classifying any news? For example, taking some random propaganda or taking some random piece of news and classifying it?
Like now?
Like, yeah, yes, if that is possible. If not, then no questions more.
Currently, I wouldn't show you on this PC.
Okay. Then no questions more.
Dear colleagues?
Yeah, may I ask
More
some?
questions? Yeah, please.
Yeah. Thank you for your presentation. I just wondering if you kind of consider some privacy of information you are going to use to build your ML model. What I mean, as I understand, now you are using only public available news to train your model. Yeah, is that correct?
Yes, from Hugging Face and other sources.
Yeah. What is about if you are going to use some part of some kind of sensitive information? Did you consider such cases, and what should be improved or changed in your model, in your approach to take into account this case?
Currently, we didn't consider it because, like fake news, we look only on public sources, so we don't use like private information. If there would be some I think there wouldn't be like private information, because what we take is like news are outside in the internet and we would just use them. We wouldn't like incorporate any private information for this system.
Yeah, I see. Thank you.
Thank you so much for the presentation. Once more again, dear colleagues, more questions? If there are no more questions, then we go to our next presentation. That is by Serhiy Bolovsyak, Nazar Hrynik, Kudzenbik, Krystyna Odajska, and Ivana Yanchuk. The topic is improving accuracy of photogrammetry method using image segmentation by YOLO neural networks. Do we have a presenter here?
Yes, I am here. I am speaker. I will share my screen. 1 second, please. Can you see my screen?
Yes, we do.
Okay. I am glad to be here. Hello, everyone. The topic of the paper is improving accuracy of photogrammetry method using image segmentation by YOLO neural networks. The content of the presentation is shown on the slide. Motivation and state of the art. The purpose of the photogrammetry method is to build 3D models of physical objects based on a series of their digital photographs. The photogrammetry method is used to build in particular 3D models of geographical, natural, and other objects. Examples of 3D models are shown in the figures. here and here. A significant problem is the application of the photogrammetry method is that for photographs, in addition to the object under study, often contain image of extraneous objects. Such objects in the images can lead to defects in the 3D models. The aim of the work is to increase the accuracy of constructions 3D models of objects using the photogrammetry method, which is implemented in the proposed information technology by pre-processing a series of images, namely by segmenting images using neural network YOLO and highlighting segments of certain classes as object masks. The objective of research is the information technology for building 3D models using the photogrammetry method. The figures show how 3D models are built from a set of images like this. Consider the proposed information technology for building 3D models and process of construction 3D model. In information technology for construction 3D models of object using the photogrammetry method, it is proposed which provides an increase in the accuracy of construction 3D models using image segmentation by neural network YOLO. The process of construction 3D model includes the following steps. First is reading a series of photos, segmentation of images by neural network YOLO, extraction of masks for segments, calculation of scaled image, dilation of the mask, filtering mask, obtaining a masked image by multiplying the image and mask, forming a set of initial and masked images. And building 3D model by photogrammetry based on a set of images using the Zephyr. The initial images is written to the array image. The mask convolving with Gaussian filter kernel WG with standard deviation sigma HD. The filtered image with smoothed edges is calculated by the formula below. Consider software implementation of object mask selection. The software for masking images of object was developed in Python in the Google Colab. Image segmentation was performed by a convolution neural network YOLO V8 using the IntelITSIS library. Medium-sized neural network model for image segmentation is created. The method predict of the YOLO model array receives the initial image as an input and returns the result or object, which contains information about the predicted masks, coordinates of the bounding boxes, classes, and probabilities. Scaled image is performed using the bicubic interpolation method. The filtering of the mask with Gaussian filter kernel is performed by the function Gaussian filter. And a result of construction 3D model of an object without masking. Let us consider an example of construction 3D model of a bench in the Zephyr software based on image without masking. The construction of 3D model consists first spare point cloud, dense point cloud, meshes of polygons, texture meshes. The coefficient of the relative number of images taken into account when building the model KL equal 1 is. The picture shows fragment of the set of initial images of the object here. The constructed 3D model without image masking is shown in picture 2. Picture 3 shows fragments of the 3D model as triangulation grid, approximately 40% of the surface of the area supports is damaged. We can see it here and here, like this. A result of construction 3D model of an object with masking. Let us consider an example of construction 3D model of a bench in the Zephyr based on images after masking. Picture 4 shows image of the object highlighted by frame. It's a initial image and a masked image here. Picture 5 shows selection of the mask of the studied object, initial mask and mask after scaling, dilation and smoothing. In the case of building 3D model only based on images after masking, some of images are not taken into account by Zephyr. 17 images with 23 were selected. Here. Construction 3D model with masking. A significantly better quality of the model is obtained when using simultaneously images without masks and images with mask for its construction. Smaller distortion of the 3D model were obtained in the case of the mask with clear boundaries. We used only 44 from 46 images. Picture 6 shows 3D models as a triangulated mesh with textures. Images without a mask and images with a clear mask were used to build the 3D model. 3D model as a triangulation mesh with textures. The model is built simultaneously on the basis of images without mask and images with a clear mask. The resulting model is of high quality. We can see it here and here. Quality better here. The picture shows fragments of the 3D models as a triangulation mesh. The model is built simultaneously on the basis of images without mask and images with a clear mask. The surfaces of the rear supports are practically not damaged. And also we can see it here, here, and here. And conclusions. And information technology for construction 3D models of object using the photogrammetry method is proposed, which provides an increase in the accuracy of construction 3D models due to automatic masking of images. The software YOLO Mask 24 was developed in Python, which is designed for segmentation, scaling, dilation, filtering, and masking of object images. Image segmentation is performed by a convolution neural network YOLO V8. 3D models were constructed using the Zephyr program based on 23 images without masking using the photogrammetry. The accuracy of most of object model is satisfactory. However, defects appeared in the rear part of the model. Approximately 40% of the surface of the rear supports is damaged. The novelty of the work is the simultaneous use of image of object without masking and with masking to build their 3D models using photogrammetry. 3D models were built using the Zephyr program based on 46 images without masking and with masking. Height accuracy was obtained for all parts of the 3D model. Thank you for your attention.
Thank you so much for the presentation. Dear colleagues, any questions, please?
Yes, may I ask a question about how fast this works?
We use only 46 images, and it's small points of photos, and we can build 3D models fast, average fast, how we can say.
Thank you. No more questions.
Thanks.
Dear colleagues, any other questions, please? If there are no more questions, then thank you so much for the presentation, and we go to the next presenter and presentation. Всеволод Сенківський, Ірина Піх, Альона Кудряшова, Роман Андрієв, and Nazari Сенківський, Evaluation of Methods for Intellectual Analysis of Manipulative Content in the Information Space. Do I have the speaker here?
Yes, you do. It is me.
Okay,
So
great.
I'm going to share my screen. Just okay. I have problem technical with the sharing.
The sharing is available for everyone.
It's on my site. I have to reopen Zoom. Just will be in 1 minute.
Then, if you don't mind, we will go to this next presentation,
Okay.
and yours will be after that.
Agreed.
Okay.
Thank you. Yeah.
Great. Then, if we have the next authors, Володимир Кисіль, Ольга Драчук, Анатолій Король, Валентина Гненна, and Елена Зайцева, Liminal Effect for AI-generated models, investigating compression techniques for maximized performance in the glaucoma diagnosis and prognosis. Do we have the speakers for this presentation?
Yes.
Then, if you don't mind, I offer you to present now, and the speaker who has technical problems will present after you.
Okay.
Are you ready?
So yes, I'm ready.
Great.
Is the screen sharing right now?
No.
And now?
Now, yes, we are starting to see the screen, please.
Okay, so how I was started properly.
Excuse me, could you please, go back to the presentation, because we started seeing the script. Now the
Yeah, okay.
presentation.
Okay, so what I would start with is that nowadays there comes the theme about the neural networks when deployed in constrained environments comes to the point where networks have to be more efficient and more accurate. At the same time, they need to save space. In the current presentation, I will tell about how and what I did to achieve and to measure the most effective compression with least accuracy losses. So the starting point about compression is that there are three key pieces. The first piece is the size of the network. The second piece is its accuracy, and the third piece is the network's time of completion. So the problem is with this is it happens on all over the networks. The network that was used for this problem was selected a common network, and the problem that was evaluated is the problem of binary classification. Actually, it was the thing that wasn't at hand, and what it was evaluated about. It was evaluated about how fast and how good it can be on constrained environments. The problem is about this is that not every environment has a GPU board to use. So I decided to evaluate how far it can be compressed and how good it can be sped up on environments with things like, I would say, on a normal laptop. Normally, networks use quite a lot of memory, normal, not compressed. For feature extractions, networks use approximately from 50 to, I would say, highest to about 500 megabytes per network, and inference times there goes for the CPU is for CPU is slow. It's about 2 to 4 seconds, depending on the network. So I decided to pick one of the networks that it is good for compressing and test how good it can be compressed. Here was used VGG networks because they are very good at the iterative compressing. ResNet is smaller in size depending on version, and it wasn't used for compressing because it has currently because it has experience blocks and they are pretty they need very careful handling. And in this research or evaluation, I was trying to do it fast and pretty much carelessly. So optimization techniques that were used here are knowledge distillation. This is when it goes from master to student network. Next is pruning that was used when networks is gradually compressed with transfer learning from larger to smaller network. Next is quantization. This is applied to previous two when networks are quantized in how do I say it properly? Their precision is decreased for a result, and weak sharing. When networks have their bits shared between, and this leading to model being smaller because their bits are reused. So baseline model looks like this. 1 second. So it goes straightforward to a nice fine-grained binary mask. Well, it also uses some preprocessing, but this is out of the scope. I won't tell about this much. And the model goes quite large. The models that are used resulted in around 128 million parameters as baseline VGG model and some transformers. Due to CPU limitation, it was quite slow, around 0.6 seconds. The complexity of this model is comprises of around 17 features. These features that are studied are from high to low level, and most of them were captured on part 4 of the model. So as we see, there is part 1 with 64, then still is 128, 256, and 512. So most features that were required for capturing needed places on model were captured here and then upsampled into a better place. Also, there were used skip connections. After compressing, oh sorry, I need to make an overview. So compression methods that about knowledge distillation and pruning, they were pretty much aggressive. So this came from aggressive pruning, where each next iteration was halved in size, and dropout also was used to make model more robust, so it forces model to remember features in several places of a lawyer. Next thing was quantization, that was about quantizing to pretty much low accuracy, and weight sharing that was attempted but actually not successful. So model was shrunk by 2 times and then even more times. These are comparative results. About Now the results about model distillation. These are configurations that were tested and their appropriate characteristics. For knowledge distillations, it took more epochs, and I would say that in depth it was required to decrease learning rate when epoch was sufficiently high enough because it stopped converging. For knowledge distillation, training took less time than for aggressive pruning in total. For aggressive pruning, it took about 13 hours for total training, and for knowledge distillations, it took way less time because for aggressive pruning, it required to retrain to train additional model additionally after each pruning. Inference time was decreased from around 0.6 seconds to 10 times less. However, the knowledge distillation failed around edge cases and around accuracy when it went to around 10 when it went to less than 10 times with S of size. Also, there were false detections, additional false detections. These are parts of results that did not contain the source feature. Aggressive pruning in this case required less epochs and converged slightly faster. It also took less time to train each type of configuration. And according to this table, it is seen that accuracy and precision of aggressive pruning is higher than of knowledge distillations with less training epochs. So it is slightly undertrained. However, it is better in accuracy. And it does have its caveats, and caveats is that it captures slightly side places or side artifacts sometimes. And the positive feature of aggressive pruning that it carried edge cases where feature was located on the side of detection range, and it retained those detections. Weak sharing was not successful. These are results of weak sharing. I did try several times to train the model so it would, how do I say it, accommodate the weak sharing that would be applied, but it didn't succeed. This is the best result of weak sharing I could achieve. So it is not good for in this case. And quantization application results. Due to how CPU handles all of this, there were no effects on inference time. And size was not really much decreased, even because how it is saved. Edge cases explanation is that there are subtle visibilities of features. For example, the left side shows a part of optics disc that is located at the border of image. Knowledge distillation started losing these side features pretty fast. And subtle visibility examples. The right side is issues that knowledge distillation had. It started capturing features that are not connected to features that were actually searched for, and it did not start dropping them, no matter how high the loss was set. So evaluation that of the total results is that best balance was found at 16 pruning. Of course, it can be trained better and squeezed even harder for around 8 times, but in the case of that squeezing, there need to be no the requirement is there should be no dropout. So the X8 model that was actually compressed to around 2 megabytes. Oh, how much? Around 2 megabytes that I would love to use. From around 150 that was source, it failed to train and started losing accuracy. Inference time was lowered pretty much low, around five times. And from my experience for CPU bound networks, that quantization and weight sharing are ineffective in this case. So the optimal compression level was around 16. So optimal compression level is around 8 times compression. This is all that I wanted to say.
Thank you so much for the presentation. Dear colleagues, any questions, please? Oh, okay, then I have one question. Volodymyr, tell me, please, what is the future implementation of your method? Are you planning to develop a system or something else? Could you tell us, please?
I plan to use this to drastically decrease the size of multiple detectors that I am going to use in assembly for detecting different features and for processing medical images.
Thank you so much. Our colleagues, any other questions, please? If there are no questions, then thank you for the presentation, and we come back to the previous presentation. Is everything all right now? Are you able to present the
I hope so. Attempt number 2. So tell me if you see my screen, please.
Yes, we do. Oh, yeah, perfect.
Perfect. Good. So I am going to show you the evaluation of methods for the intellectual analysis of the manipulative content in the information space. It is our teamwork. So introduction. In the context of growing information threats, there is a growing need to develop and improve methods of intelligent analysis that allow for efficient detection, identification, and evaluation of false content. The research in this area is aimed at developing algorithmic and analytical approaches that provide the detection of sites of manipulation, analysis of information sources, and determination of its reliability level. The efficiency evaluation of such approaches can be based on the Pareto principle, which will be used in this evaluation of methods, which allows selecting optimal solutions based on the criteria of accuracy, speed, and resource consumption. For example, deep learning models demonstrate high accuracy, but require significant computing resources, while classical machine learning methods are less expensive, but may be inferior in the ability to recognize complex manipulative structures. The selection of a specific approach depends on the characteristics of the information environment in which the analysis is carried out, as well as one of the needs for accuracy and speed of data processing. So what does mean Pareto principle? As you know, Pareto principle, as you know, it is the rule of the 80-20. And in this article, we are going to use the concept of Pareto optimality, which defines a set of solutions that cannot be improved on one criterion without worsening another. What does it mean? That no solution in the Pareto set is dominant over another, and the selection of the particular option depends on priorities or additional conditions set by the researcher or the receiving party. And the first methods to evaluate is logistic regression, support vector method, and decision tree. A feature of Pareto set is its adaptability to a specific task. It allows one to identify compromise solutions that take into account different aspects of the problem and provides a basis for further analysis and decision-making. Since none of the option is unambiguously the best according to all criteria, the selection of the final solution is often made taking into account additional priorities or weight factors that represent the significance of each criterion in a specific context. To solve this Pareto principle, we have to use the formation of the expert group. And just imagine that we have to analyze the method which evaluates the data. Is it fake or not? And we have the expert from 1 to m and the factors. And in this case, we are going to use the scale rating method. So we create the algorithm, and the main idea that each parameter has to be bigger or equal with some level of trusty. And in this method, we have 3 options, like the pair of values satisfy the relation, one satisfy, or several areas satisfying the relation. And we just said that our trusty equivalent is 50, and the scale will be from the 0 to 8. And this is our formation like 0. And on the formation 1, we just group into the 11 groups, and we will have such the parameters, and do so a few times. And finally, we will have the result, like the area 1 to 8 will be above above or equal the 50% level. This means 25, and we will determine the value, and it will be 4. So we have to compare to the average value of the entire scale. It is 5, which means that we have the result of this method, like the generalizing scale scores during group examination ensures the formation of the most reliable indicator of generalized opinion for any distribution of expert data. The center of grouping of score, which with a symmetric distribution of score coincides with the weighted average value. So this method of the scale rating is can be used for the evaluation of the trustee of the information. The second method, it is the method of linear convolution of criteria, and it uses another concept called the generation of alternative options. It has a similar, how would say, approach, but we have to use an alternative options for the weighting of each criteria. Pardon. And just I will show the final result that we have the formula for the weight of each criteria presented here. And we have to do experiment just to compare those methods. And pairwise comparison metrics of messages evaluation criteria. We set these metrics, and combination of efficiency shares of criteria in alternate options. That means for this method of linear convolution, we have to set those options, and for our theory, it has to be sum of the 100. So we have so many different ways of criteria, and the final result are following. We have these parameters. And also we have the functional model of the algorithm for automated determination of the optimal method for evaluating the probability of information messages, which can be using in the creating system or programming. Thus, based on the results of the conducted study, the most effective method for assessing the credibility of messages, in our case, is the support vector machine. This method is based on finding the hyperlane that maximally separates different data classes in the feature space, making it optimal for binary classification tasks, such as distinguish reliable information from disinformation or manipulative content. However, the application of CVM for message credibility assessment also has certain limitations. One of the key challenges is the complexity of interpreting the results, as SVM does not provide clear explanations regarding which specific test features influenced the classification. Additionally, this method is sensitive to imbalanced datasets, where one category of messages significantly outweighs the other, which can distort classification results. And the conclusion that the result of the study confirmed the relevance of the problem of evaluating methods of intellectual analysis and detecting manipulative content in the information space. Determining the most efficient method is a key task for ensuring the information security and containing disinformation. And in this article, we just put our attention on those two methods and trying to evaluate it correctly. That's it. That's it from my side for today. Thank you for the attention.
Thank you so much for the presentation, dear colleagues. Any questions to the speaker, please? Okay, I have one question. Could you please tell us about the aim of your research? I mean, the big purpose, because I think this presentation, this very particular research is a part of something bigger, if I'm not mistaken.
Yeah, you are correct. So the main task is to know which information is fake or not, because we live in the world when we face to face with the deep fake even videos, and our research is to aim the efficiency of the methods which tell us is it information good or not. So just to in different situation, we have to choose which methods is operate. So it's that like only for evaluation those methods. And in the final result, it increase the probability do not use the fake information in our lives.
Thank you. But what criteria do you mean under the you told that which information is good or not? Maybe you meant correct or true, something like that.
In this research, we use, I have to share again my screen. We have such like accuracy, speed, resource capability, interoperability, and we can just add another criteria which need to evaluate.
Thank you. Then it is more clear what do you mean under the good information. Thank you so much, dear colleagues. Any other questions, please? If there are no more questions, then we go to the next presentation by Vitaly Alexeiko, Huda El-Bouhisi, Valeria Shvaiko, and Andrei Kuzmin. A web-based information system for land surface temperature forecasting, its role in the context of the ecological imperative and educational challenges of the digital society. Is the speaker here?
Good afternoon. Can you see
Good
my
afternoon.
presentation?
Please?
Can you see my presentation?
Yes, please.
Okay. My name is Vitaly Alexeiko, and I'm a PhD student. I'm pleased to present our paper titled Web-Based Information System for Land Surface Temperature Forecasting, its role in the context of the ecological imperative and educational challenges of the digital society. We represent Khmelnytsky National University and University of Béjaïa, Algeria. The authors of this study, Vitaly Alexeiko, a PhD student majoring in Information Systems and Technologies, Huda El-Bouhisi, PhD, Associated Professor, Faculty of Exact Sciences, Land Laboratory, Béjaïa, Algeria, Valeria Shvaiko and Andrei Kuzmin, master students majoring in computer engineering and programming. The modern world is dynamically changing. The development of science and technology contributes to the emergence of new technologies that are quickly integrated into all spheres of human life. This creates a need for highly qualified specialists capable of transforming society on the way to prosperity and sustainable development. In the digital society, the problem of adapting the educational sphere to the challenges of civilization is particularly acute. According to Sustainable Development Goal SDG 4, education is one of the most powerful and proven tools for sustainable development. SDG 4 is aimed at eliminating inequality and provides for free access to quality education. The formation of environmental culture and worldview is an important component of human environmentalization. This includes awareness of the relationship between human and nature, as well as understanding the need to care for the environment. The ecological imperative becomes the regulator of relations between human and nature. This means that decision-making should take place in view of the environmental consequences. The term ecological imperative was introduced by the German philosopher Hans Jonas in his book Das Prinzip Verantwortung, in English, The Principle of Responsibility, in which he formulated an ecological maximum of action based on Immanuel Kant's categorical imperative. Act so that the consequences of your action are compatible with the continuum of true human life on Earth. Researchers note that environmental hazards that exist in today's condition are the result of a low level of environmental culture in the past. It was proposed a web-based information system for land surface temperature forecasting using long short-term memory method. This tool provides an ability to discover historical temperatures and compare them with data forecasted by AI. To determine relevance of implementing proposed information system into educational process, it was provided an analysis of using AI tools in educational institutions. As part of the research, a survey of the participants of the educational process was conducted on the basis of the Khmelnytsky National University and the State Educational Institution Khmelnytsky Center of Vocational and Technical Education of the service sector. Regarding the use of AI technologies for educational purposes. Two target audiences survey identified students and lecturers. The survey was conducted anonymously in compliance with ethical principles. Confidentiality of respondents' personal information is ensured. All data are presented in a generalized form. 135 students, among them 84 students of higher education institutions and 51 students of professional educational institutions, and 45 lecturers took part in the survey. The distribution of education seekers by courses is presented in figure. Among the surveyed education seekers, 17% indicated that they use artificial intelligence technologies very often, 30% often, 29% sometimes, 18% rarely. At the same time, only 5% do not use AI in everyday life. The survey among lecturers noted that 4% use AI technologies very often, 31% often, 34% sometimes, 23% rarely, and 6% do not use them. Educational seekers noted that they most often use AI for learning and as a source of information. Technology is most rarely used for entertainment. 36% of respondents use AI models for work, and over 30% use AI for data analytics. It should be noted that among students of IT specialties, this indicator is about 45%. The main areas of application of AI models among lecturers are work and the use of technology as a source of information. 23% of surveyed lecturers use AI for training, 10% for entertainment. 19% of lecturers use AI models as a means of data analytics. In general, the majority of respondents positively evaluate their experience of interacting with software products with implemented AI models, 60% among students and over 50% among lecturers, 35% of students and 44% of lecturers describe their experience as neutral, and only 4% of students and only 2% of lecturers describe their experience as negative. According to the majority of students, AI technologies exert a positive influence on the educational process. About 66%, 17% of respondents did not note any impact, and 8% noted a negative impact. 70% of lecturers positively evaluate the impact of AI technologies on the educational process. 19% believe that such an impact is absent, and 10% evaluate it negatively. This figure visualizes the frequency of use of digital content created with the help of AI for educational purposes. Both among students and among lecturers, there is no unequivocal opinion about determining the level of interest of education seekers in studying disciplines, provided that AI technologies are used in the educational process. 43% of students and over 44% of lecturers noted that it is currently difficult to determine the impact of AI on interest in the educational process. At the same time, 43% of students and 40% of lecturers note a positive influence, and 12% of students and 12% of lecturers described it as negative. It should be noted that the vast majority of both students and lecturers expressed interest in using AI technologies in the educational process and plan to use them in the future. 33% of students and 90% of lecturers were undecided, and only 10% of students and 5% of lecturers indicated that they are not interested in implementing technologies in the educational sector and do not plan to use it. In general, the use of AI technologies is in the educational process will contribute to the development of professional abilities, taking into account environmental problems, a responsible use of resources, and nature management, as well as achieving the goals of sustainable development by forming among students a holistic understanding of the current problem of the planet and society. Nowadays, environmental challenges present humanity with a double task, the harmonization of relations in the human nature system and the formation of a new type of person who takes into account ecological aspects in his actions. Achieving SDGs is a key development point for UN member states on the path to peace and prosperity. Preservation of the ecosystem for future generations is very important to sustainable development. The vast majority of scientific and pedagogical workers positively evaluate their experience of integration with AI and positively evaluate the use of AI technologies for educational purposes. At the same time, the survey of educational seekers noted the respondents' high interest in the introduction of technology into the educational process. Thus, web-based information system for land surface temperature forecasting can be integrated into educational process for better understanding environmental processes and potential risk caused by climate change. The use of the proposed approach in the educational process will contribute to the formation and development of environmental awareness of students of secondary, professional, vocational, and higher education institutions. Thank you for attention. Maybe you have any questions.
Thank you so much for the presentation, dear colleagues. Any questions, please? I have one little question, Vitaly and Tim. What is the form of the implementation of your system and what is the purpose of its further use? Have you considered that?
We have, first of all, the aim of this research is to understand if it is interested to use such systems in educational process. And as for our system, we decided to provide further research to make it more understandable for students, for educational seekers on the different levels, to help them understand nowadays environmental problem and to form ecological awareness and make them prepare them better for future negative consequences of climate change.
Thank you so much for the speech and for the research. If there are no other questions, we go to the next presentation. That is by Anatoly Sachenko, Victoria Vysotska, Sergey Vladov, Natalia Vladova, and Danilo Shved. Intelligent method for the helicopter turboshaft engines gas temperature determining under rapid changes in its various conditions. Do we have a speaker here?
Good day, my name is Sergey Vladov. Do you see my presentation?
Not in a full screen mode.
But, and this, see my presentation?
Dear colleagues, can you see the presentation? Because I have some, now it's perfect. Yes.
Yes, I'm started.
Yes, please.
Thank you. I present our research intelligent methods for the helicopter turboshaft engines gas temperature determining under rapid change in its various conditions. Modern helicopter turboshaft engines operate under significant dynamic loads requiring precise control of operating parameters. However, traditional methods for measuring the gas temperature in front of the compressor turbine, a key indicator of engine efficiency and reliability, are hindered by sensor inertia, interference, and varying condition, necessitating the development
development of intelligent adaptive temperature assessment method using neural network for real-time performance prediction. The helicopter turboshaft engine's gas temperature accurate measurement remains challenging due to the limitation of traditional thermocouple sensors under dynamic conditions and the complex calibration requirements of alternative mathematical methods. A promising solution in the integration of hybrid machine learning and mathematical modeling algorithm into onboard engine monitoring systems to adapt to transit modes and improve real-time prediction accuracy. The proposed method combines adaptive neural network algorithm with physical and mathematical modeling to accurately determine gas temperature under rapidly changing conditions, compensating for sensors inertia, and interference. It integrated an LSTM-based predictive model, a correlation physical model that accounts for external factors, and Bayesian filtering module to ensure high accuracy and adaptability. The proposed method consists of 4K modules, a data pre-processing system that clean and normalize sensor signals using wavelet transformation, a neural network predictive module based on LSTM with adaptive learning, a physical and mathematical model for calculation theoretical gas temperature values, and an integrated module that fuses this result in us using a Kalman filter. The neural network module leverages historical temperature data and engine parameters to predict gas temperature, while the physical model accounts for dynamic heat losses, turbulence, and changing operating modes. This table outlines the proposed method's algorithm, detailing 6 stages from data collection and preliminary processing to neural network prediction, physical model calculation, integrating using Bayesian correction, and final data update. Each stage addresses a specific aspect of temperature assessment, ensuring comprehensive monitoring and control of helicopter turboshaft engine performance. The predictive module predicts the gas temperature using an LSTM network that adapts to changing engine characteristics by processing historical sensor data and real-time parameters. Its architecture comprises an input layer and LSTM layer with 4 get input and output gates, a fully connected layer, and an output layer that delivers the predicted temperature value. A computational experiment was conducted using data from the TV3117 engine on a Mi-8 MTV helicopter with onboard sensor recording parameters during a 320 seconds real flight at a 0.25 second sampling rate. The recorded data were sequentially processed: noise reduction, outlier elimination, and Z normalization. This illustrated in this figure. Based on the presented diagrams, a parameters training datasets was forming, which fragment is presented in this table. The diagrams illustrate how the LSTM neural network model and the Kalman filters sequentially improve the gas temperature data quality by first smoothing noise and then eliminating jump to closely match real measurements. The original noise black curve is partially smoothed by the neural network red curve, while the Kalman filter refines in future into a smooth this is blue curves. Left top figure illustrated that the adaptive coefficient increase the root mean square error for adaptive model decreases steadily, unlike the non-adaptive model, which exhibits higher end fluctuation errors. Left bottom figure demonstrates that the filter efficiency reduces not in the temperature derivative pressure when the essential dynamic of transit temperature changes. This figure shows that the LSTE model 22 milliseconds yields a narrow error distribution with a small spread, while the physical mathematical model 37 milliseconds has a more diffuse distribution due to its complex calculation. The combined methods 55 milliseconds, which integrated both approaches using a Kalman filter, further reduced the overall prediction error and spread. The conclusions are presented in this slide. Thank for attention.
Thank you so much for the presentation. And dear colleagues, questions, please. Okay, then I have a little question. Serhiy, what was the basis of your research? Why did you start doing this research? I mean, researching the helicopter's behavior inside the engine.
Mm-hmm. This research is a part of our globally research from developed expert system for complex monitoring helicopter turboshaft engine implemented by onboard system. By our time, we used many computer model and one experimental software beta version. This complex research implemented by many publication in world journals.
Thank you so much. So this is a part of the big research. Thank you.
Yes. And this research is a part of our big research. Thank you.
Great. Then if we don't have more questions, we go to the next presentation that is by Olga Pavlova, Andrei Kuzmin, Maria Kostyuk, Alexander Khlevnoy, and Huda Buhisi, computer vision-based information system for landfill fire detection. And the presenter is Andrei Kuzmin. Please.
Hello, dear participants of the conference. My name is Andrei Kuzmin, and I am a master student of Khmelnytsky National University, majoring in computer engineering. Let me introduce the computer vision-based information system for landfill fire detection. I live and study in Khmelnytsky. This slide presents Khmelnytsky solid waste landfill, which is located on the territory of the city. This photo were taken by us as a part of the tour organized by the Khmelnytsky Smart Environment Office. We visited the municipal landfill with our supervisor and other students who are interested in this problem. Admittedly, its scale is impressive. We decided to conduct research in this direction because we searched through a lot of sources and found many terrible cases of landfill. Here are some of them. In May 2016, there was a fire at the Hribovichi landfill near Lviv. 4 people died due to a debris slide. The work of the landfill was stopped. Garbage from Lviv started to be taken to other landfills in the region and Ukraine. Unfortunately, these cases are not rare in Ukraine because of the accumulation of methane due to the decomposition of waste and due to the increase in the average annual air temperature, global warming. Fires often occur in landfills. They are dangerous because they spread quickly, occupying a large area, emit harmful and poisonous substances into the air, are difficult to extinguish. The slide shows putting off a fire at a landfill near Rivne. The fire covered an area of more than 300 square meters. To eliminate the fire, 6 rescue tanks, a tactical robot, 3 local fire brigades, and equipment serving the landfill were involved. Although during the fire at the landfill, hazardous gases and compounds that pollute air, grounds, and water are being released. And dangerous phenomenon of this subject is leachate, liquid with a complex chemical composition with a pronounced unpleasant smell of biogas, which rises as a result of the accumulation of atmospheric precipitation in the landfill and concentrates within its soil and is extremely poisonous. To solve the problem of landfill fire detection, we propose an information system that consists of 3 subsystems. Surveillance cameras that includes CCTV cameras as a landfill area image recognition subsystem that uses the pre-trained neural network model and alarm signal subsystem that provides the conclusion about fire of the absence of fire at the landfill. The architecture of the proposed system is shown on the slide. For the operation of the proposed system, a method of early landfill fire detection was developed. It was presented in more detail in our previous works. The method consists of 6 steps: preparation and training of a neural network model on a dataset with smoke and fire classification, validation of the neural network model on real images of fire at landfills, automatic detection of fire at landfill in videos from outdoor surveillance cameras, and saving images using the existing ULV8 model, using Python program, manual verification of recognition results, separation of cases of false detection of fire or smoke, evaluation of the automated detection quality, manual labeling of incorrectly processed images. In the case of study, the experiments with YOLO-V8S neural network were conducted. For the model training, a method of supervised learning was used. It consists in the fact that the algorithm is trained on a pre-classified dataset, which simplifies the search for objects for recognition and increases the accuracy of recognition. Training of the model was conducted on RoboFlow dataset with two classes, smoke and fire, using Python programming language and Google Colab environment. An example of image classification of the above mentioned dataset and examples of the images for training are displayed on the slide. Yowie 8S model was chosen as it has optimal parameters for solving this task. The result of the algorithm operation of the subject of smoke and fire detection on real images of landfill fires taken from the internet are presented on the slide. However, we can see that the smoke and fire on these images is significant. The accuracy of the recognition is not sufficient enough. Further step in our research will be devoted to training the model at the images with a smaller amount of smoke and train it how to distinguish smoke from the fog and other weather conditions that can influence on the quality of the recognition. The paper proposes the concept of an information system for detecting fires in landfill using computer vision highlights the importance of artificial intelligence driven solution in enhancing fire detection and prevention, contributing to improved safety measures in high-risk environments. Further work of the authors should focus on integrating additional sensor data, improving model robustness, and deploying the system in diverse waste management facilities to validate its effectiveness in real-world applications. Also, the authors plan to mitigate the errors occurred during the experiments. Thank you for your attention.
Dear colleagues, any questions, please? Thanks for attention and for speaker for this presentation. Any questions, please?
I have one question about what data did you use for your experiments? Was it real data from Ukraine, from other countries, etc.?
Andrei, could you please answer the question about the data set?
I use dataset from RoboFlow dataset library.
Okay, I can continue the answer as a supervisor of this work. The data, actually, this is the research that is really difficult to get real data because landfill fires happen not every day, and this is the accident. So we cannot just go to the landfill that is burning and just get the images from it. So that's why we used the ready completed data set from RoboFlow that was labeled by two classes, fire and smoke, that helps us to distinguish the results in capturing the fire-like and smoke-like pixels. However, there is it's not, it doesn't give accurate results because sometimes the neural network masks the fog and the clouds with the smoke. So that is one of the next steps in our research to train the model how to distinguish the fog and the clouds from the smoke like pixels.
Thank you so much.
Thank you. If there are no more questions to the speaker, then thank you so much.
I have
Okay.
one question. Dear speakers, my question, how did you measure the accuracy of your system?
I can also answer if Andrei doesn't mind. Actually, we conducted the experiments using the data set, and we used the YOLO V8 model. We trained this model on the data set because the data set was split by the 3 parts: the training data, validation data, and test data. So that's why we trained the model on this data set, and then we processed the validation and the training and got the results, and the accuracy was presented. It's actually the part of our previous paper, previous research. There was a confusion matrix, and we measured the accuracy by the formulas. We counted it, and that's why we got these results. But we didn't present them in this presentation because it's not the like focus and not the material of the paper that was given to this conference. So that's why not to mess up the results with the previous paper. We just mentioned it, but not provided them in the slide.
Thank you, your answer.
Thank you so much. Dear participants, if there are no more questions, then we go to our last presentation, and the speakers are Alona Kudryashova, Irena Pich, Vsavolod Sienkiewski, Taras Oliyarnik, and Alexey Bilik. The topic is Designing an Intelligent System for Digital Image Classification. Is the speaker here?
Yes, hello, I'm here.
Good afternoon.
Yeah, let me share my screen. Can you see my screen?
Yes, perfect.
Okay, so my name is Taras Oliyarnik, and today I will present the result of our study. The topic name is Designing Intelligent System for Digital Image Classification. This study presents an intelligent system architecture for digital image classification that integrates machine learning and analytical models to enhance accuracy, stability, and adaptability by prioritizing key factors through expert evaluation and mathematical modeling. Digital images are widely used in fields such as medicine, education, architecture, and publishing, where they enhance analysis, visualization, and communication. In medicine, they help detect diseases and track treatment progress, while in education, they improve learning through interactive and visual materials. Architecture relies on digital images for designing visualization and structural analysis, whereas publishing depends on image quality for high-quality printed materials. The rapid growth of visual data necessitates advanced image classification techniques, with artificial intelligence and machine learning playing a key role in automating this process. Raster images made up of pixel arrays are among the most commonly used digital images, with quality determined by factors like resolution, color depth, file format, compression, etc. Image quality can degrade at various stages, such as acquisition, compression, transmission, and display, making accurate quality assessment essential. There are both subjective and objective methods for evaluating image quality, including absolute and comparative approaches. The subjective evaluation depends on human perception and environmental factors, while objective methods rely on measurable parameters such as sharpness and contrast. Predictive assessment models offer an advantage by allowing adjustments to input parameters to optimize image quality. The primary goal of this study are to develop a model that prioritizes factors respecting raster image quality. To enhance classification accuracy, design a general architecture for intelligent digital image classification system, and create a diagram outlining the class process for model execution. Expert relation methods have been used to establish a set of factors affecting the quality of raster images, such as resolution, color depth, color model, file format, file size, image size, compression, brightness, saturation, and sharpness. Here below you can see influence factors and their dependencies between each other. The method of mathematical modeling of hierarchies was used to determine the priority levels of the identified factors. The essence of the method is to build an accessibility matrix, which contains binary elements that indicate the presence or absence of relationship between analyzed pair of factors. If there is a relationship between the two factors, the corresponding element takes value 1, which reflects their interaction. In the absence of relationship, 0 is indicated. Here is the formula. According to this logic, a matrix of the availability of factors influencing the quality of raster images was constructed. For convenience, it is presented in tabular form. Here in the table 1, we can see this reachability matrix of factors. The accessibility of one factor to another is determined based on interconnections identified by the expert method. The subset of factors that can be reached from a particular vertex forms the set of its reach. At the same time, a subset of factors for which a given factor is reachable form the set of predecessors. The intersection of these sets determines the group of factors with a dominant influence. Iterative tables were created using the data present in a reachability matrix. If the data in the third and fourth piles coincide, the priority of the factors is considered to be determined. Here in table 2, we can see the first level of iteration. And during this iteration, we determined the first level of priority factors, and they are resolution and color model. Table 3 shows the second level, determines second level of priority factors. They are color depth, file format, image size. Table 4 shows the third level of influence factor. They are compression, brightness, and saturation. The last level force can be seen on table 5. They are file size and sharpness. According to this, the result of the iteration, the following distribution of factors by priority levels was obtained. And respectively, the model of the priority influence factor on digital image quality has the next form. You can see it on figure 1, all 4 levels. Modeling the priority influence of factors facilitates a reasonable choice of preprocessing and analysis method, which is necessary to improve the accuracy and stability of classification. The developed model of the priority influence of factors makes it possible to select high-quality images for further classification. Therefore, the next stage of the study is to design the architecture of an intelligent raster image classification system. You can see it on figure 2. The system architecture consists of 4 main components: the application, the data subsystem, the training module, and the execution module. The application serves as the primary user interface, enabling data entry, management, and visualization of processing result. Key elements include an image screen for loading graphical data and a result screen for displaying classification and text descriptions. Iterative controls facilitate data input, result clearing, and process initiation. The data subsystem manages training sets with graphical objects and textual annotation for model training. It includes a tokenizer for text vectorization, a classification module for image categorization, and a description module for generating text annotations. Input test images assess system accuracy, while results contain classification data and descriptive texts. Training module provides algorithmic tools for building, training, and optimizing classification models and text generators. It includes mechanisms for data transformation and adaptation, ensuring efficient use of training sets in modeling process. An execution model handles computational operations and image analysis algorithms. It integrates all processing tasks, featuring a classifier for categorizing images and description generator for creating text descriptors. The generator utilizes a tokenizer to transform text data into format suitable for neural network processing. For a better understanding of the program's component architecture, a class diagram has been created. In the initial step, necessary libraries are imported to work with models, images, and text data. Next, the system checks for the presence of an input image passed via command line. In case if the argument is missing or the corresponding file cannot be found, the system generates error message and stops execution. If the image is loaded correctly, the system proceeds to the main processing procedures, predefining global variables that contain paths to models and files required for further analysis stages. The next step is to initialize the utility functions. One function load and processes the input image, preparing it for classification. Another function loads the model, which is used to extract features from images. Additionally, pre-trained models are loaded to divide images into categories and classify them into subcategories. At the final stage, the tokenizer and the model for generating image captions are applied. Data is extracted from the graphic object to create a text description automatically. The signature generation is based on the mechanism of long short-term memory. As a result, the program structure generates and outputs results that contain all the defined categories and the generated text description for the input image. Conclusion. A set of factors influencing the quality of digital images is defined. A multi-level model of the priority influence of factors on the quality of digital raster images has been developed. Based on the result of the iterative analysis, 4 levels of priority of factors influencing the quality of digital images were identified. The first level, resolution and color model. Second level, color depth, file format, and image size. Level 3, compression, brightness, saturation. And fourth level, file size, sharpness. The architecture of an intelligent digital image classification system was developed, consisting of 4 main components: an application, data subsystem, training model, and execution model. Also, class diagram was built, which illustrates the logic of interaction between system components and image processing procedures. The results of the study allow us to reasonably choose methods of image processing, increasing the accuracy and classification stability. The developed system has the potential to be used in practical tasks of raster image analysis. Thank you for your attention. That's all from my side.
Thank you so much for the presentation. Dear Taras, dear colleagues, any questions, please, to our presenter, to our speaker? I have one question. Could you please turn the slides to the very beginning? Could you please explain, you called the research and intelligence system. What traits, what characteristics of intelligent systems, I mean the classic ones, does your system have?
I think yes, our system contains a training model which use data subsystem to train model and use it for execution model to classify and categorize images based on training results. So I guess it should contain all required elements of intelligence system.
So it gives the new data, yes, if we talk about the classic representation of intelligence systems.
Yes.
Thank you so much for the presentation, dear colleagues. We are on a finished part of this section. And now we have a lunch break because at 2 p.m. we start our second section of the workshop, systems and systems of informational security. So thanks to all for great presentations and discussion, and see you at 2 p.m.
See you.
Thank you so much.
Нема нічого ні.
Hello, dear colleagues.
Hello.
Glad to meet you.
Nice to meet you too.
Dear colleagues, let's continue our workshop, and we have our session, System Information and Security, I will be moderator. Okay, the next presenter, I suppose it must be Vyacheslav Kovtun, with topic Adaptive Management of Communication Resource Allocation in High-Load 5G Infrastructure, a queuing-based approach. Are you ready?
Yes, thank you. I am ready. Give me a minute, please.
Vyacheslav, please keep the schedule 15 minutes, please.
Okay. Okay, dear colleagues. Dear colleagues, let me present you the results of research work titled Adaptive Management of Communication Resource Allocation in High-Load 5G Infrastructure, a Quaquin-based approach. Let's continue. Let's continue to the motivation. Under a real-world operating condition, traffic in 5G networks is far from uniform. There are distinct peaks, usage periods shaped by user behavior, and this clearly illustrated by the figure 1, which depicts a typical fluctuation of in base station load over 20-hour periods, highlighting significant morning and evening peaks that result in critical congregation zones. Figure 2 demonstrates that classical modeling approach, such as M1 Quaquin systems, is while computatively simple, but fail in reflect the actual characteristics of 5G traffic. They do not account for service delays between request arrival and processing, user mobility, and dynamics changes in the traffic density. In this case, we move into our proposal, and consequently there is a processing need to develop adaptive models for communication resource management that can predict traffic behavior, reduce latency, and dynamically optimize resource utilization in real time. The Quaquin model, which delay proposed in our research, accounts for key behavior patterns in the traffic flow. So the object of our research is the process of managing communication resource distribution in high-load 5G infrastructure. Research aim is to formalize a delay-aware mathematical model that ensures efficient resource utilization while reducing service latency. To model the distribution of communication resource in high-load 5G infrastructure, we propose a Quaquin system which extends the classical model by explicitly incorporating latency effects between the arrival and service of subscriber requests. This structure reflects real-world factors such as buffering, handovers, and processing delays, which are critical in dense 5G deployments. Here at the slide, we propose delay-aware distribution functions. And now we move into the key metrics of our system, which are correspond to proposed model. In this matrix, we see that we take into account we can take into account mean inter-arrival time, mean service time, base station utilization, and such statistical characteristics as coefficient of variation for arrivals and coefficient of variation for service. Using Laplace transforms and Lindsay integral equation, we derive the Laplace transform to the of the waiting time distribution in the form of evaluation, which is present on this slide. So now let's move to the results, which we calculate using our mathematical apparatus. In figure 4, we can see the relationship between the average waiting time F and base station utilization U and the coefficient of variation CV mu. It compares the performance of the delay-based Quaquin model, which is a classical MM1 model under varying traffic irregularity. The results demonstrate a fundamental distribution between the two models. In the delay-aware model, the average waiting time remains stable and bounded even at high utilization levels and elevated variability in traffic demonstrated by the parameter CV mu. This indicates the model's capacity to adapt to fluctuation in request flow and avoid performance collapse near saturation. Now we move to the figure 5 that presents the dependency between the base station utilization U and the coefficient of variation of incoming traffic C mu for different values of request intensivity mu. This experiment illustrates how utilization responds to the growing irregulation in traffic and compares the behavior of the delay-aware model described at the left and the classical MM1 model described at the right. The results show a clear contrast. In the delay-aware model, base station utilization increases smoothly and predictably as both mu and C mu rise. This indicates the model's sensitivity to traffic variability and its ability to adapt resource distribution accordingly. Even under high irregular input flows, when the value of coefficient C mu is high, the system maintains a stable utilization growth, which adapt jumps. At figure 6, we can see the relationship between the average waiting time F and the utilization level U of the base station and the delay duration T0, comparing the proposed delay-aware model described at the left and the classic MM1 model presented at the right. The results clearly demonstrate the sensitivity of the delay-based model to changes in the value of T0 parameter, especially under high conditions, high load conditions. As T0 increases, the average waiting time grows significantly, and this effect intensifies, which increasing the level of utilization U. This behavior reflects real-world 5G infrastructure dynamics, where even slight increases in the service delay can have a substantial negative impact on service quality, particularly when the system is near saturation. So the conclusion. This study introduced delay-aware Quaquin model for adaptive communication resource management in high-load 5G infrastructure. The model incorporates delay-shifted exponential distribution to reflect the real-world traffic irregularities and service latency. Enabling predictive control over utilization and service quality. Experimental validation across free traffic dynamic regimens, low, medium, and high, reviewed that the proposed model ensures stable Quaquin behavior and outperforms classical model in conditions of bursty traffic, high user mobility, and near saturation utilization. Thank you for your attention, dear colleagues, and I'm ready to answer your questions.
Thank you for your presentation, Vyacheslav. Colleagues, any questions, please? So, Vyacheslav, what is the main scientific impact of your research?
As usual, the main scientific impact is the mathematical model that is more precision in reflecting the 5G infrastructure behavior in higher load scenarios. This mathematical model is based on the Quaquin theory, but it is moderated using such a basic parameter as a delay, which we present here at this slide. I'm not present a high level of mathematics evaluation at the presentation because of because as usual it is not very good to view such a big formulas, but all colleagues which are interested in this topic can, I hope, see this in the thesis which will publish soon.
Okay, colleagues, any more questions? No? So, Vyacheslav, thank you for your interesting presentation. And
thank you very much, dear colleagues.
So the next presenter, the topic is selection of models for operational management for hierarchically structured systems under threats. Who will be speaker?
Yes, hey everyone. My name is Folo. I'll be speaking on behalf of other authors today. Do you see my screen currently with the presentation?
Yeah, yes, we do.
Great. Okay, I'll start then. Good afternoon, everyone. My name is Pavlo, and I'll be presenting our paper, Selection of Models for Operational Management of Hierarchically Structured Systems Under Threats. This was done by a bunch of researchers from National University Lviv Polytechnic. And motivation here stems directly from real-world conditions, specifically the operational complexity and unpredictability of systems that were exposed to crisis environments like war, cyber attacks, or natural disasters. Our goal here is, in this study, was to develop and formalize models that allow complex hierarchical systems like energy grids, production lines, emergency infrastructures to maintain control under active threats. The approach was based on 3 management levels: situational, operational, and calendar or scheduler. We use categorical models and some game theory to model uncertainty and functional diagrams to visualize decision chains and risks. And these models were built not for clarity more, but for action. They tend to enhance the ability to plan, allocate resources, and adapt control procedures in real time. For introduction, model control systems often separate technical and strategic decision-making, but in a crisis that usually doesn't work. Like imagine a situation where you have a missile threat or a natural disaster coming your way and you can't wait to gather a board meeting or gather a bunch of people to decide what to do. You need to architecture that supports immediate tactical and strategical responses also all at once. Our objectives here were to build models for that and to define critical threat factors and to support real-time preventive decisions using formal methodologies and trying to put it all in math as well. State-of-the-art approaches currently cover a broad range of related work, from classical control theory to more modern uses of semantic and fuzzy modeling, both real-time and non-real-time. Many of these focus on separate problems, for example, long-term planning, local optimizations, or specific calculations for risks. However, very few systems integrate all 3 levels of control into a unified reactive framework. Additionally, while these categorical models have been used in niche areas, they haven't been combined with dynamic programming for emergency response. One of the major challenges currently is that the operators, in this case, human decision makers, are often treated as external to the model. And in our work, we tried to integrate them as agents, the like human in the loop approach, allowing them to coordinate with machines even in time-sensitive or unpredictable threat conditions. As mentioned, the proposed 3-tier control structure is situational level that handles immediate responses, operational level that coordinates resource use and process flow, and calendar level that supports long-term objectives or strategical planning. We used categorical modeling to map out how systems behave, and parts of game theory models simulate behavior under incomplete or adversarial information, something that's highly relevant with these high entropy situations. And functional diagrams serve as logical maps, basically, for these scenarios. To dive slightly more deep into those 3 key models, for hierarchical model management, we connect strategic, local, and external threat factors. It reflects how data, decisions, and threats flow through the organization. The operational action model that's displayed on Figure 1 shows how resources, logic, and decisions interlock on the micro and macro levels of the system components. So think of it like a workflow of potentially programmable actions or that react or proactively act on different triggers that could be set up by humans or dynamically by machines. And the dynamic system model uses metrics, differential equations described in the paper. They represent how the system evolves under the influence of inputs and controls over time. Based on the simulation run internally, like we've tested the model, we've achieved in this simulated environment speed and precision planning, stability of control loops, and the coordination of responses between strategic and operational units. We used dynamic programming to simulate that, and what's novel here is the coordination across hierarchy levels. There is some the next slide for conclusions, future work. Moving forward, we plan to enhance the protective aspects and coordination aspects between those 3 key levels, particularly for critical infrastructure, and to integrate our work into deployable decision support systems. And in summary, this was built as a framework for decision making in high-risk environments. And we've aimed to achieve forming a new categorical model for local targeted control, hierarchical linking between 3 different levels to focus on real-time and strategic actions, and incorporate equations to adapt the model in the real time and involve humans in a human-in-the-loop model so that humans will affect how the model behaves and adapts long-term. For more details and for formulae are available in the paper. That's it. Thank you for your attention. We'll be happy to answer any of your questions, and feel free to contact us through the emails listed here.
Thank you, Pablo. Dear colleagues, any questions? Okay, I have one. Pablo, can you say, please, you said that there is some approach concerning selections of models. Is there any possibility to add new models in some situation if you need?
Yeah, that's totally could be designed to be plug in, plug out model situation. Imagine on programmable level when implementing this could be developed using an adapter pattern, for example, where any company or system that wants to integrate this specific situation with 3 hierarchical levels could integrate their models and pipe in and pipe out different models of data that could impact the way that we did the calculations. Right now, this was simulated on a very limited set of data, but in general, this could be expanded to how, for example, the workflows software is working and being operated right now.
Okay, thank you for your answer. Colleagues, any more questions, please? No? Okay, thank you. Let's move on. Okay, the next present will be a speech concerning to modeling and adapting more network databases for complex data structures. Who will be presenter?
Hello, Volodymyr Chernyak is presenter.
Yeah, please.
Okay, welcome to my presentation on modeling and adapting network databases for complex data structures. Today I will outline you how we build concepts on a classic network database principles and combine them with modern techniques like machine learning and distributed architectures. First, we will revisit the historical context of network databases and see how they compare to other approaches like relational graph and NoSQL. Next, we will explore our multi-tier design that uses AI-based optimization to handle queries efficiently. We will also discuss the technology stack, including Python and containerization. Then we will describe our test environment for running high-load experiments on large graphs. Finally, we will cover how the system performs under diverse workloads, discuss the result comparing it to relational and graph databases, and conclude with potential next steps. Historically, CODASIL and IMS set the foundation for navigational data handling. They excelled in environments with well-defined relationships, but lacked flexibility for changing schemas. Over time, they were overshadowed by simpler relational models. Modern datasets often grow unpredictably, rendering rigid schemas inefficient. Network databases never fully adapted those larger-scale, evolving scenarios. As data complexity rose, traditional solutions struggled to keep up. A relational database focuses on struggled queries but can incur heavy overheads for joining in complex relationships. Graph databases handle a relationship more efficiently, yet may lack certain transactional or high-volume advantages. NoSQL systems are flexible but often sacrifice consistency or advanced querying. By revisiting network databases principles and injecting modern distributed and AI-driven strategies, we aim to harness their navigational strength. This hybrid approach could bridge gaps in adaptability, scalability, and robust query handling. This diagram compares relational, network, and graph databases in terms of structure, scalability, and flexibility. Each model excels at certain tasks, yet faces inherent limits when data becomes highly dynamic. The relational is to demonstrate how a refined network-based approach combined with model methods may address these gaps. We separated concerns by having a clear client layer, a computational layer, and a distributed storage layer. The computational layer integrates AI to optimize queries dynamically. This fosters both performance gains and flexibility. The client layer is responsible for receiving requests and passing them on for processing. It also provides end user with streamlined interface to run analytical queries. This design ensures minimal overhead at the entry point. In computational layer, machine learning algorithms learn usage patterns and predict query loads. By routing or parallelizing tasks, this layer achieves better resource allocation. The result is reduced latency under skippy workloads. In storage layer is shared and replicated across multiple nodes, enabling horizontal growth. If the dataset expands, we simply add more containerized instances. This ensures consistent performance even with millions of nodes and edges. This illustration outlines a step-by-step procedure, building a large model, introducing incremental changes, and then stress testing under high query loads. The goal is to observe how a database system adapts as both data volume and structure evolve. Machine learning models may be integrated toward the end to optimize query performance. This schematic depicts a client tier, a computational tier, and storage tier working together. The client tier accepts and routes queries, the computational tier handles parallel processing and potential AI-based optimization, and the storage tier scales horizontally for large data sets. For experimental setup, we constructed a synthetic social network to match real-life complexity. Each node simulates a user and edge indicate interaction or connections. This ensures we thoroughly test the system's capacity. By containerizing each component, we ensure a reproducible result and straightforward scaling. Prometheus and Grafana collect and visualize performance metrics. Our framework supports incremental additions or deletion of nodes and edges. This mimics platforms like social networks where data structures evolve constantly. We measured how quickly the system adapts without performance drops. We choose this task for their practical relevance in graph analytics, from finding the quickest route to detecting influential nodes. Link prediction extends usage to recommendation system, making it a vital real-world scenario. This code snippet shows how network X in Python can be applied to process large graph. This approach draws on navigation principles similar to those found in traditional network databases, argument by contemporary distributed techniques. It is designed for scenarios such as social network, where a million of nodes and edge are common. We tested beyond 1,000 simultaneous queries to simulate a busy web platform. This ensures we captured worst-case scenario behavior for real-time analytics, even though the system remains responsive. When new nodes or edges are added, the system adjusts without significant rebuilds. This is crucial for continuously evolving datasets, like IoT streams or social networks. We observed minimal lags compared to static approaches. Machine learning algorithms analyze workload patterns and primitively distribute queries. In peak time, throughput sees notable bumps, sometimes exceeding 20%. This balancing prevents bottlenecks and saturates resources efficiently. As the datasets grow by 70% or more, we still maintain nearly constant query execution time. Horizontal scaling of containers and robust distribution keep performance from degrading. This stability sets our solution apart from many conventional DBs. This table lists average time for pathfinding, centrality assessment, and link prediction across multiple database solutions. The network-oriented approach records shorter query duration, suggesting better efficiently with relationship-heavy data. This finding highlights how an adaptive connection-focused design might surpass rigid or purely relational models. An expected performance improvement of up to 40% compared to relational databases. Based on theoretical assessment, the system may offer significant acceleration for query involving intensive graph traversal. This advantage is particularly relevant for tasks such as certainty analysis or complex link prediction, where the overhead associated with multiple table join in relational models can become a limiting factor. Scaling up the datasets didn't cause significant slowdowns or timeouts. This suggests our solution can handle rapid expansion typical in modern big data ecosystem. Memory and CPU usage also remain within acceptable limits. Social networks, IoT devices, and fast-changing enterprise data often outgrow static models. Our incremental update approach ensures we can add or remove relationships in real time. This agility sets the stage for future real-time analytics. Although machine learning adds some computational cost, the net effective is positive. Predictive modeling of queries leads to short-term overheads, but yield faster responses under load. For big unpredictable datasets, they trade-offs pays off well. The final diagram represents key expansion incorporating real-time stream platform like Kafka or Flink, enhancing machine learning models and testing cloud-based scalability. Particular focus is placed on continual adaptation to evolving data relationship. Such advancement aim to maintain system responsible and efficient under unpredictable workloads. And that's all. Thank you for your attention.
Thank you, Volodymyr. Dear colleagues, do you have any questions, please? Okay. As far as we understood, you are dealing with databases. Can you apply your research results to big data approaches?
To big data approaches?
Yep. So you are trying to... Yeah, please.
Yes, I think we can do this, but I didn't any research in this topic.
Okay, because you can actually somehow you can apply your research to that direction. Thank you. Okay, colleagues, more questions? No? Okay, let's go to the next speaker. It's detection of computer attacks based on sonification of network traffic. Who will be speaker?
Yes, hello, I will be speaker.
Okay, Bogdan, please.
Moment, let me share correctly my screen. Could you help me there? Do you see it? Or sorry, you are muted.
Yeah, we see.
Yes, thank you, because I have 3 monitors, not sure what's selected. Okay, that's sorry, it's a bit wrong. Let me reshare again. Okay. I think now it works.
Now everything is okay, please.
Yeah, I'm just changing the monitor. So yeah. Yeah, let me start there. And yeah, good day, everyone. Yeah, today I want to present the work titled is Detection of
computer attacks based on sonification of network traffic. My name is Bogdan, and I will be the presenter there. So this resource was constructed between two universities, as was mentioned in topics. And yeah, just for first look, yeah, it's mostly sounding usual and that, but I will demonstrate how the approach works. Okay. The next one is introduction. So nowadays computer actually generate a lot of and massive amounts of traffic that make it is difficult to detect sophisticated instructions. Traditional IDS systems, intrusions detection systems often produce numerous false positives results, and they miss some modified attacks or new not known signatures. So here deploying approaches come in handy and often pose some advantages in this area, with which also relies on large training data amounts. So but let's say representation of that is still remains a challenge. So here is the turn of idea of sonification of traffic. And first, just interesting how the difference between normal and anomaly traffic looks like, because we know it's easy to speak but hard to imagine. Yes, next one. Motivation of that. So let me underscore on that study. Traditionally, ML-based IDS system works with one-dimension feature vector in the input. While this works, we might lose some subtle relationships among attributes. However, we took inspiration from two different areas. So first one, don't correctly remember naming, but it was related to one research was done in this also area in IDS system based also on machine learning. So guys proposed the idea that they took that vector, converting that to image, and then using the standard image recognition networks to detect anomalies. So I was very interesting how it works. And the second one, this from where the term sonification comes from, it's also was research where group was tested on group a new approach with additional alert channel for center of sorry, moment. Yeah, for security center, where they providing new additional channel for pinging them, like they already know, they already has some approaches to track anomalies, like visually, or yeah, but they are also prepared that sound-based alerts. So it was like also interesting to test how different anomalies were sound like, and that like helped them to quickly and fast do something on that. Yeah. So here is we combine it to this idea, and the final question sounds like could converting of traffic features into audio signal, and then work with well-known practices for analyzing sounds or speech works at all. So yeah, right, that works is mostly working. It's mostly you should start working with what data you work. So it's more like type or presentation of data, because like it could be packet-based technique was mostly focused on individual packets, and details like IDs or content is shown there. And next one is the flow-based, where you work with aggregated data in some time interval. So this was the where we work in that also flow-based. And also we have a session-based with communication for communication between two endpoints, and log-based is mostly about analyzing text and exact logs of exact applications. So it's a bit different area. So we are choosing the second one, flow-based. Yeah, proposed approach. So we take data set known like very basic data set KDD known for that typical problem solution. And we like do that. Firstly, we have this vector, we do normalization. Then we do one hot conversion to convert like enums to binary view. After that, apply the conversion to exact signal. So we create that pseudo audio file, but we do not save that file. We just do this sinusoidal wave. And after that, we apply also short Fourier to create a two-dimensional image with spectrogram, which one we use for, already use it for that classification two-dimensional CNN. So yeah, this one is visual presentation of waves. Like say that we have two examples. First is where we work with the normal traffic, and the second when we have that anomaly one, and here we could see visually difference in what time, let's say, time point or time window we see this anomaly, and we could understand patterns. Yeah, visually is more like, for me personally, it's more understandable to rely on some patterns and see how DOS or other DDoS or brute force attacks looks like, and it's more, I guess, understandable for newbies also. Yes. The next one is representation of spectrogram and first Fourier transform. So here we had this heat map, which is limited by 5,000 hertz, is caused by performing, because for that test was used Google Colab, and at some point if you use full 16K hertz frequency, so we could receive that out of range exception is for some limitations. So it also has place to be to think about some optimization of things. And also we have in result computed sound size 0.4 seconds. And yeah, also could see difference between anomaly and normal one. And yeah, experimental setup, as I mentioned, is known data set is KDD. So after encoding, we have 122 features, and we convert it to 4,000 hertz with duration 0.1 second. And after that, we also split that to windows, and with 256 samples in each one. And then we have basic settings for double dimension CNN. The next one is training results, which first two charts we have like results and that learning in approach. Sorry. So we see that in our model not over learning, but we keep it as etalon for what that means. Training accuracy is 96%, which is quite okay for that. and the test was 76%, around 77, and yeah, we have interesting points that attack detection and recall around 62%, which means we have a bit loose, and our assessment do not recognize fully on the test test run all attacks. So we have the tools, but in comparison, I would say that to common approach with same without computation, we have a close numbers like typical straightforward approach with one dimension CNN give us a score around 78%, and that means that's okay results, and it's my place to be that it's yeah, we have actual results, not just in words. And yeah, advantages of that give us opportunity to use some audio techniques, not just yeah, let's say simple, not just the numbers. We could reuse something from audio and speech recognition word. Also, it gives us opportunity to visualization and do some analysis on that with human adaptive and human understandable waves. Also, yeah, it's plus and minus that we also depends on time and frequency data. Like frequency is simulated thing, but time is for us mandatory. And yeah, after adding that additional converting to sound and then Fourier as that transform was added, we achieved like that errors that out of range, and it also increased learning time in too much, so was kept at frequency. So that also things to think. Conclusions. So yeah, we have yeah, we have that result around 77%, which is very typical for that data set and for that problem. So that means that is overall combination of PCM and short Fourier plus double the CNN works and could be supplementary or alternative method for IDS. The future directions. So idea is to use GPUs their resources for extend frequency because of large calculations and slow down application at all. Yeah, create some visualization methods, may select some other patterns and see how they work, and also mark some extreme dots of anomaly or try to recognize exact patterns and show them. Also, parameter selection correctly, it's just correctly configure the model and make sure we get max from that configuration. Also, could try multi-attack classification instead of just simple is it anomaly or not detection. We could try classify to exact class or exact attack type it is. Maybe it will work better because we will extend the frequency and that CNN will clearly understand what pattern it is. And yeah, maybe also idea is to use existing audio methods to boost up accuracy, because yeah, it was not done investigation in that area. Maybe we should reuse something from existing approaches where, for example, like Shazam do or something like that. And yeah, that's it from that point. Thank you for attention.
Thank you, Bogdan. Dear colleagues, do you have any questions? Okay, I have one. What are the main limitations of your approach?
Okay, let me back to the slide. That means that we have a first limitation on time sequencing. So we deeply work with that two ASICs like time and frequency, and we could not work with other type of data. So we should work only with that sorted in time, and that's why was that data set selected. And the other one is just the cost of resources and of performance. So that's very hard operation to manage just this additional converting into signal, and after that to Fourier plus heat map. So it's required additional adjustment there.
So the continuation of question is, are there any ways to overcome these problems?
I think yes. First, we need to keep attention on our model and correctly configure it. And after that, we could say, okay, we have correctly working model. Then we could extend our course, like use the GPU or some. I remember we could convert it on C++ or C# CUDA we have. Maybe we could integrate this with that approach. And also we could, for example, I have that in my sets, use some boosting up methods, like we could increase some, like, in audio, you could increase higher or lower frequency, like bass or, so maybe we could reuse something there and we'll see other results.
Okay, thank you for your answer. Colleagues, more questions? No? Okay, thank you, Bogdan.
Thank you. Have a good
and
one.
We go to the next presentation. Method of random dynamic control transfer between network nodes for the partially centralized operated system security system. Who will be speaker?
I will speak.
Yeah, please, Yuri.
Do you see my screen?
Yes, we do. Please.
Okay.
You have 15
So,
minutes.
dear guest, I am going to present you a report on the topic method of random dynamic control transfer between network nodes for a partially centralized OS security system. Postgraduate student, assistant of Department of Computer Engineering and Information System, Yuri Stetsuk, will deliver the report. Operation system are the main, most functionally complex software system of computer systems, which are tasked with managing the resources of a computer system. The comprehensive process of developing communication in the field of IT technologies has imposed more stringent conditions on the function of network OSs in terms of ensuring information security. Their relevance continues to grow due to the continuous growth of the sophistication of malicious actions in computer network and the growth of the skills of the attackers themselves. Therefore, to ensure the stability of network systems, their architecture must be based on a powerful security system in which the necessary protective mechanism must be synthesized from forced access control, privilege minimization to network backup and control, data integrity and authenticity control, which are components of each security system. The OS protection mechanism discussed above provide a potentially high level of protection for network computer systems. However, there are still many unresolved security problems. The main ones are the use of decentralized method of privilege management in most existing network OSs, the introduction of centralized method of resource management as an alternative of decentralized method leads to appearance of a bottleneck in the system in the form of a central control node, which can be targeted to malicious software attacks. Software vulnerabilities that appear from time to time in OS modules and now also hardware vulnerabilities of processors, the complexity of which is such that the probability of the presence of vulnerabilities in them is close to 1, lead to poorly predicate consequence for the security system. A number of local problems of individual losses when the system user is considered a trusted person and is not perceived as a potential attacker who can knowingly or unknowingly gain authorized access to information. Therefore, the goal of our research is to develop methods that will improve the situation with the above-mentioned problems of network or security system. The presented model of the centralized OS security system of network node allows obtaining an OS security architecture with a low probability of leakage of confidential information during low-level malware attacks. As one of the ways to overcome the shortcomings of the centralized OS security system while preserving its positive qualities, a method of dynamic control transfer between network nodes during its operation is proposed. The method is based on the constant migration of the control center across network nodes, which allows getting rid of the main drawback of pool centralized approach to the presence of a bottleneck in the form of vulnerabilities in the central control module. According to the proposed method, the computer network is represented as a set of nodes, formal 1. In this case, each CSMM module of the node is associated with the local privilege base. All local privilege bases of network nodes can be represented by set formula 2. We define the state of the system at the time preceding the transfer of control by formula 3. Then the transfer of token can be described as translation, formula 4. Upon receipt of a control token, the dynamic control transfer method will involve updating the main privilege base for the node to which control of the computer network is transferred by replicating the local privilege bases of active network nodes at the time of changing the network control center. First, a set of local privilege bases that are in the current state determined over which a replication operation is performed in order to obtain the current privilege base of the central node. The algorithm of a dynamic control transfer method includes the steps: preparation for transfer, where the state in which the current central control mode is located is evaluated, transfer of the current system state, active session, security policies, and system monitoring status, activation of new module. After receiving the control token, the node activates itself as a central module. To access the effects of the dynamic control transfer method, we will use a set of mathematical and probabilistic models that take into account the following indicators: the probability of leakage of confidential information, which takes into account the effectiveness of the OS protective mechanism, the time to detect a threat, the time to process security operations. Then combination of all three parameters, formula 10, will determine the effectiveness of the centralized security system. And formula 11, which takes into account the application of the dynamic control transfer method by nodes, will determine the effectiveness of the partially centralized system. For the experiments of test environment was deployed based on the use of virtual computer network, which includes virtual target machines, VAM VM01, VM04 running as a FreeBSD 31 OS with a modified kernel, and the attacking machine VM00 running on a Kali Linux OS and the Metasploit framework attack simulator. The calculation performed based on the experimental data shows that the effectiveness of the partially centralized OS security system, despite its complexity, as can be seen from the graph, is noticeably higher, which ensures its lower vulnerability to leakage of confidential information. Thus, the use of dynamic control transfer method allowed us to preserve the main advantages of centralized security system, which concerns the system's resistance of information leakage, at the same time get rid of its biggest drawback, the bottleneck in the form of a central control module. The second advantage of this method is that periodic random change of the network control node makes the results of the attacker network reconnaissance irrelevant, thereby disrupting attacks before they even begin. Thanks for your attention. Maybe questions.
Thank you, Yuri. Dear colleagues, do you have any questions? Speaker? No? Yuri, what is the main disadvantage of your approach, and what are the false positives of the detection?
Use of dynamic control transfer method allowed us preserve main advantages of centralized security systems. It get rid of its biggest drawback to bottleneck in the form of central control model. And the second advantages, as I say, is method is a periodic random change of the network control node make a result of attackers network reconnaissance irrelevant because database with privileges moving all time between all computers in this network system.
Thank you. Okay, so I have no questions. Somebody else has any? No? So, okay, let's move on. Thank you, Yuri, for your presentation. The next speech is method for detecting anomalies in IoT device traffic based on statistical analysis using the modified z-score. Who will be presenter?
Good day, everyone, dear colleagues. One moment for prepare my presentation. Everyone see my presentation? Yes?
Yeah. Yes, we see. Please.
Okay, let's begin. Good afternoon, dear colleagues. We will present research method of detection anomaly in IoT device traffic based on statistic analysis modified z-score. This work focus on lightweight, accurate anomaly detection in dynamic IoT environments. The approach designed with practical deployment in mind and aims strike between balance and simplicity. One moment. Motivation. The rapid growth of IoT devices, over 17 billion in 2024, face increasing attack surface. Each device becomes a potential vulnerability. This makes real-time anomaly detection more critical than ever. Our goal is to offer the lightweight solution that scales with device growth and dynamic behavior, while minimizing resource consumption and configuration complexity. Research goal. Our objective is to develop method that works in real-time, requires no training, and adapts to dynamic traffic while being lightweight enough for low-power IoT devices. The method should detect both short-term anomaly, like burst, and long-term drift. It must also reduce false positives to avoid alert fatigue. Robustness and adaptability are key priority. The core concept, instead of using machine learning, we rely on statistic profiling. We construct a normal behavior profile for each device using a modified z-score based on median and med, ensuring resistance to noise and outliers. This approach enables unsupervised detection without needing labeled data. It adapts to behavior of each individual device. Thresholds can be adjusted for sensitivity control. Detection workflow. The process consists of data collection, profile generation, deviation detection, anomaly scoring, filtering, and finally anomaly index output. Each step improves precision and reduces false positives. First, normal ranges are calculated for each parameter. Then, deviation analyzed based on intensity and duration. Filtering removes low-weight anomaly. The final anomaly index reflects over device behavior. This modular pipeline allows for easy tuning and scalability. The key formula. First, we define the normal range using the median and multipliers of median, absolute deviation, MED. This gives upper and lower bounds for expected behavior. Then we check how far each value is from median divided by the med. This gives us a normalization deviation, the z-score, which is more stable than traditional version. Each deviation is raised to a power for sensitivity and multiplied by parameter-specific weight. Summing them gives us a final score that reflects the intensity and importance of anomalies. This process helps us detect both short score that summarize the current state of device. Weighting and filtering. Not all anomalies matter equally. Each parameter is assigned a weight based on signification. The filtering rules priorities in factual deviation while discarding noise and fluctuation. The scoring process amplifies more critical events such as repeated login failures over minimal jitter and timing. The exponent amplifies larger deviation, making strong anomalies stand out more clearly. Ultimately, this yields one anomaly score per device at each moment. This score can be tracked over time or used for real-time alert. Synthetic log generation. To validate our approach, we generate logs using statistical distribution. We simulated realistic traffic and injected control anomaly, including message burst, failed logins, and delay. Each anomaly type was time tagged for validation. Logs reflect diverse behavior profiles, mirroring real-time deployment scenarios. This allowed for reproducible testing and fine-tuning of detection thresholds. Anomaly types. We simulated anomaly across 5 types: message frequency, login issue, repeat patterns, timing irregularities, and connection accuracy. This helps assess the method sensitivity and robustness. Each type targets a specific behavior dimension. Intervals capture time-based anomalies, which repetition captures structural patterns. Combined, they simulate realistic threats. This setup ensures that the method can generate across a broad range of possible attacks. Time series graph. This graph isolates how anomalies are detected over time. Spikes and drops indicate abnormal behavior, while black crosses show isolated anomalies. The red line represents detected behavior, while the dotted yellow line shows expected traffic. Temporal localization is a key identifying persistent with rare events. Visual inspection confirms accurate detection. This visualization demonstrates that the method efficiency in detection, sudden change, and adapting to a normal shift. Evaluation methods. We use precision, recall, and F1 score. Our method achieves 86.7% precision, 90% recall, and 88.3% F1 score indicate both accuracy and stability. This metric we computed across all anomaly types. Precision ensures low false positive is critical and automated environments. Recall reflect detection, competition, and robustness. F1 balance the two and gives a practical performance summary. Detection accuracy. This table shows per anomaly accuracy high score 91% achieved for message interval anomaly. The lowest 68.9% for repeated messages due to minimal visible changes. Other types show balanced performance. The breakdown helps us understand which deviations are more distinguished. It informs future improvements and helps prioritize time and effort for specific behavior. A method compression. We compared our method with autocoder, Rosner test, Holt Winters, isolation forest, and one-class CVM. While autocoder lets scores, our method often competition result with low complexity. Holt Winters struggled with irregular pattern. Rosner test had similar precision but lower recall. Isolation forward and class CVM required more configuration. Sorry. Advantages. Key advantages. Not need training, high noise tolerance, fast execution, and low resource use. It adapts well to heterogeneous device and network condition. Thresholds and weight can be tuned to context, suitable for edge devices and embedded systems. The modularity and transparency of methods support real integration into larger monitoring ecosystem. Conclusion. In conclusion, method provides a robust, efficient, and practical approach to anomaly detection IoT. Future work will explore the expanded parameter sets and deployment in real-time traffic environments. Future validation or real-world data is planned. Integration in monitoring platform is another direction. This approach is modular and extensible. We believe it provides strong foundation for real-time anomaly detection system. Thank you for your attention. Have you any question?
Thank you, Mykola. Dear colleagues, do you have any questions, please? No? Okay, I have one. Why did you need to modify Z-score metric? You used modified Z-score. Why do you need to modify it?
Modified the score used for more determine parameters for our normal median. We have more accuracy parameters for low and high Planck. I think I don't know how to say in English. That's why we have more accuracy for deviation of our device, and we then in future can accuracy understand what he meant, and in time we see that it's anomaly or it's a simple broke of IoT device.
Okay, thank you. And have you compared modified and not modified that score to make decision that that's modified is more appropriate, that it shows better result? Have you compared it? Modified and not modified?
It will be in our next of our research. In this one
Okay,
of our.
thank you.
Thank
I
you
see.
too.
Okay.
Thank you.
Okay, so colleagues, let's go on. The next presentation, cybersecurity of robot sorting system of warehouse assets of a printing company. Who will be speaker? Petro, please.
Thank you.
You have 15 minutes.
Thank you. Dear colleagues, for attention present the research cybersecurity of robotic sorting systems of warehouse asset of printing company. Relevant of the topic is the automation of the warehouse in printing increases the effectivity of logistic at the same time vulnerability is a cyber attack. And purpose of the study is to develop the effective model of cyber protection. The main sets it's DOS attack, mine in the middle, data tampering, sensor spooling, social engineering, and RFID spoofing. For the research, we used the robot platform MicroBot 280. Tools is the robot operation system, MATLAB simulator, and AnyLogic. Protocols, the typical protocols for the connecting of this type of robot, and the traffic analysis is ZIG and Wireshark. For the research, we used the test modeling as dot overall server. The light commands might change control signal, sensor pooling changes, trajectories, and mathematical model of attack impact created. Protection models, it's industrial detection system, TLC and digital signatures, AI analysis of robot behavior, and multi-layer cyber defense model. In the study, a model of the robotic sorting system was developed in the MATLAB simulator. Like in the picture, environment using Simscape multibody, the model enables the analysis of the robotic system behavior under cyber attack, the evaluation of the effective of security measures, and the impact of security strategies of system performance. The model incorporates a motion control loop for the manipulator, which includes the following process: command generation for movement, the sine wave block, create a signal to simulate control commands. PID controller adjusts the movement of the robotic system, minimizing deviation. Command transmission of to the system data is sent to the Simulink PS converter, which convert them into physical signals. Manipulator movement execution, the revolt join calculates the position of each join and transmits the data to scope, and the impact of cyber sets signal distorting DOS generator and sensor spoofing modify control commands system protection. The anomaly detector filters out abnormal signal while TLC encrypting previews mid attack. Performance evaluation, scope visualize the manipulator's movement and security effectiveness, assess the effectiveness of the protection measures. The simulation result shows the manipulator movement without the influence of attack, like a figure, and with the influence of the DOS attack. Bottom graph, where the blue and green lines, top graph, are the normal movement of the first and second joints. The red and pink lines, bottom graph, are the manipulator movement under the influence of an attack that's causes jump-like change. As a result, the experimental study to assess the cybersecurity of robotic sorting system of printing warehouse, a test platform was used with Microbot 280, MQTT UART protocols, and AES with the machine learning. These types of the cyber attack were simulated, and like a present of the figure 3, we have no attack 0.5 second, DOS attack 5.2 second, data terminating 2.8 second, and mid it's 3.9 second. In the DOS attack caused the longest delays. Operation security rate, present result on the figure 4. No attack we have 98%. For those attack we have 45%, and data terminate we have 30%. And mid we have 55%. Effective drop at most during DOS. Error rate, like a figure 5, we have no attack, it's 2%, DOS attack 55%, data tampering 30%, and mid 45%. Errors rate was highest under the DOS attack. Impact of the attack of security measures, execution time under attack, present on the figure 6. Cyber attacks significantly increase operation time. It's no attack, it's 1.2 second. DOS attack is 6.5 second, and mid it's 4.3 second. Sensor spoofing it's 3.8 second, and DOS has the most several impact. Execution time rise our 5x. Mid and spoofing also introduce notable delays. And the error rate and cybersecurity measures, like a figure 7, tested protection mechanism reduce error. With no protection, we have 50%. EJS we have 20%, TLS 1.3 we have 10%, and AI monitoring we have 5%. AI monitoring is the most effective adapting and set and minimize error. The result obtained indicates the robotic system are very vulnerable to attack, especially DOS attack. However, the implementation of modern security mechanisms such as AI monitoring and EDRs significantly increase the stability and accuracy of operations. The optimal combination of cyber protection allows to the reduce risk and ensure a reliable operation of manipulator in difficult condition. Conclusion, the study explores critical cybersecurity challenges related to the robot sorting system employed for warehouse asset management with the printing industry, given the increasing implementation of automated logistic platforms, the potential vulnerability of such system of cyber threats, including DOS attack, man-in-the-middle attack, and manipulation and vulnerabilities without common industrial networks protocol. The primary research object is the robotic warehouse sorting system integrated with the Microbot 208 manipulator simulating real-world logistic operation in printing enterprise. Experimental modeling use MATLAB Simulink allowed for the realistic reproduction and testing of the cyber scenarios to counter identified vulnerabilities, multi-level cyber security framework, incorporating network traffic monitoring and encrypting. The research objective to enhance the security and operation reliance of the robotic warehouse system has been successfully met. Experimental results indicate significant improved in the cybersecurity reliance demonstrated by an 80% reduction in cyber threats impacts. And specifically response time and operation errors under attack condition were substantially described validation of the effectiveness of the cyber security. Thank you for your attention.
Thank you, Petro, for your presentation. Dear colleagues, do you have any questions, please? No, I have one. Can you say, have you evaluated executional complexity of your approach?
Thank you for your question. We have problem with the warehouse sorting system because it's including difficult local area network, and it's so hard for the realization of any control system. And it's very important to the robotics this manufacturing, and we used the real model, and of that we use the typical protocols which use in the printing equipment. And it's a part of the largest research, but we have this in the modeling and the real life robot.
Okay, thank you. Thank you for your answer.
Thank you.
Okay, so the next presentation is devoted to method of and means of critical information processing in corporate networks. Who will be presenter?
I will.
Yes, Alexander, please.
I try to share my screen.
You have 15 minutes, please.
Can you see my screen?
Yes, we do.
Okay. Good afternoon. My name is Alexander Hularnik, and I am pleased to present you work on the method and means of critical information processing in corporate networks. This study analyzes data leakage prevention, DLP technology, botnet trends, and integrated security architecture that helps safeguard sensitive data. Here is the outline of today's presentation. We will start with the motivation for focusing on data leaks and botnet trends that move on to the main research objective. Next, I will highlight our key findings, discuss the experimentals, and performed the final conclusion with recommendation for straight fading corporate information security. Our digital transformation efforts have led to rapidly growing data volumes, which unfortunately heightens the chance of a leak. Typically, insider issues like abuse of privilege or accidental misdelivery combined with sophisticated external threats such as botnets, which account for a significant portion of data breaches. Data loss prevention technology have thus became as essential, but they face notable challenges from accurately distinguish malicious actions to analyze encrypted traffic. The primary goal of this research is to propose and evaluate an integrated system that not only prevents data leaks, but also detects botnet-based attacks. We begin by analyzing major causes of data leaks, then divide into the range of DLP system of the market, and finally present an architecture that unites with DLP with specialized botnet detections in a single frameworks. We identify two major categories of causes in insider threats, whether malicious or accidental, and target external attacks, especially botnets. Misdelivery, for instance, remains a surprisingly frequent source of leakage, while misconfigurations or cloud resource can expose a large volume of sensitive data to the public internal. Next one, DLP a system typically combine discover, monitoring, prevention, and reporting. These are applied across endpoint and networks to protect data in use, in motion, and at rest. Despite offering robust frameworks, DLP can struggle with encryption and sophisticated insider tactics. Architecture vary from centralized to fully distributed, with hybrid often used in large enterprises. Centralized solutions simplify policy updates, but may hit performance bottleneck. Distributed systems scale more easily, yet require sophisticated synchronization. In our analysis of leading commercial DLP solution, we found each one has its own strengths, like a semantics, broad coverage, first point, a modular approach, digital guardian, strong endpoint controls. However, false positive, complex deployment, and encrypted traffic remain challenges for all. Despite their benefits, all DLP systems grant with several core issues. False positive remain a signification point is if a policy is too strict or too aware. Employees can't do their jobs without constant blocks or warnings. Additionally, as encrypted becomes the north, both of external web traffic and many internal transmissions, DLP solutions often lose visibly into the content they analyze. This forces organization to rely on endpoint agents to inspect data before encrypting, which adds overhead. Another key challenge is distribution malicious user intent from legitimate use. If an employee has authorized access to certain documents, how to we differently a normal job function from a data theft scenario. Finally, there is the question of scale. A large enterprise may generate massive network throughput, making it computationally investive for DLP to inspect or log all data flows compressively. There is a change hint at the need for more intelligent, contents-aware solutions that integrate multi-security layer. Botnets are powerful tools for cybercriminals. Each inspected machine or bot communicated with a central command and control server. Attackers can instruct these bots to scan local drivers for sensitive documents and exfiltrate them. Because botnets often use legitimate-looking protocol like HTTPS, it's challenges for traditional firewalls or antivirus software to detect malicious outbound command connections. Some advantages botnets also leverage DNS tunneling on non-standard ports to slip past network filters. Consequently, many organizations discover data because branches far too late once the harm is already done. Linking botnet detection with DLP allows us to correlate suspicion networks behavior with attempts to access or copy sensitive files or endpoints, something that a standalone system may fail to catch. In the proposed architecture of the critical information processing system, there are 4 key nodes: a computer of serve on which users work, which can be infected by a botnet, endpoint host, a small software model that monitors data manipulation, a DLP agent, and a central policy and incident management served DLP console, and a network traffic monitoring model designed to detect a botnet activity, a botnet detection. In the process of operation, the system operates as follows. When a user performs certain actions on a workstation, on server, in particular working with documents, copying file, using external media, the DLP again tries to recognize whether the files are confidential and whether the actions do not contracted as an established policy. If violations are detected, the agent sends a signal incident to the DLP console where logs can be stored and warnings for administration can be generated. At the same time, this same endpoint host generate network traffic that pass through botnet detection if the internal algorithms or signature analysis detect suspicious behavior typical of botnets. The detection model sent a signal incident to the DLP console, signalized possible damage. Then by comparing data from both source, agent, and botnet detections model, the DLP console can establish a correction if a bot-like program tries to send files silently. This became a reason to block the transfer TINET policy or inform security. This way, confidentially files cannot be transferred without knowledge or approval, and suspicious activities are immediately reported to the notification system, allowing for a repeat person to indicate. Next ones. To summarize, DLP offers a strong foundation, but must be extended to effectively cache botnet-driven leaks. Our proposed integrated approach correlate networks anomalize with DLP logs resolution in high detection rates, even with encrypted traffic or partial exfiltration attempts. To evaluate the effectiveness of proposed architecture where DLP and the botnet detections model work together, we will conduct experiment in which botnet attack with data leaks attack is simulated, and the system is tested to what extent it is able to detect and block authorized extraction of critical data. In this experiment, test bots, malware emulators installed on workstation. They try to send sensitive files via previously known channel HTTP, HTTPS. The goal is to check how the system captures this activity. On the host, where the DLP agent operates, a set of files marked as confidential financial reports, for instance, is placed. The bot emulation tries to send this file to a remote server. It is checked whether the DLP agent blocks copying of sending of prohibited files, and whether the botnet detection model detect suspicious connections. Evaluation parameter of this experiment is detection rate, the proportion of successfully detected attempts to transit critical information among all tracks. Response time, how much time passes from the moment the leaks begin to blocking on a notification. False positive, the number of a normal operation that the system mistakenly recognized as malicious. The result of the experiments are presented in a table. According to the test result, the average detection rate exceeds 90 to 95%, which indicates a fairly high ability to the system to detect attempts at authorized data extraction even under conditions of making our encryption. The average response time range from 10 to 25 seconds, depending on the complexity of the attack, which allowed for relatively quick blocking of the transfer of sensitive files. The false positive rate, which range from 2.5 to 3.5%, is considered acceptable for real corporate environments. This means that the system does not block or notify about legitimate action too often. In general, such indicators indicate the effectiveness of the processed integrated architecture in computing botnets attack aimed as stealing critical information while leaving the possibility of further configuration policies of reduce false positive indicates. In conclusion, our findings highlights that the effective defense against data leaks and cyberattacks isn't just about deploying a standalone product, be it DLP, intrusion detections, or encryption. Instead, organizations should adopt a holistic framework incorporating multiply security layers, including robust policies, well-informed staff, and integrated technologies. By unifying DLP with botnet detections capabilities, companies can dramatically cut down on missed threats, thereby reducing the window attackers have to exfiltrate critical files. There is still significant room for improvement, however. Machine learning techniques can be refined to reduce false positive, and zero trust methodology can ensure continuous verification. Equally important is deploying a DLP system that can handle a complex encryption scenario effectively. As we advance, the ability to seamlessly integrate across this domain will be a key to meeting evolving cyber threats. Thank you for your attention, and I'll be happy to take any question.
Thank you for your presentation, Alexander. Dear colleagues, do you have any questions, please?
I have one, please.
Yes, please.
Please tell me, in the situation when the most of traffic is encrypted, that is widely used in corporate networks that you have already mentioned, for example, with the protocols like HTTPS or VPN, how effectively your solution can inspect data, and do you need the decryption for everything to make it work? Thank you.
Thank you for your questions. In our system, encrypted traffic is indeed a key limitation for poorly network-based detections, we address it using endpoint agents that inspect data before it's encrypted. This way, contents can be analyzed at the source, eliminating the need to decrypt network streams in transit.
Thank you.
Thank you for the question.
Okay, thank you, Alexander. Colleagues, any questions? No? Okay, let's move on. The next presenter presentation, honeypot-based monitoring, detecting, response, and information protection framework. Who will be speaker?
I am.
Okay, please.
You see this? You see the screen?
Yes, we do.
Today I wanted to present you the report on the topic honeypot-based monitoring, the detection, response, and information protection framework. In introduction, I would say the paper present an approach to security based on honeypots. There are decoy data monitoring access to which allows detecting attacks. Honeypots effectively identify threats, particularly insider and mask virus attacks, which traditionally security measures often overlook. They help mitigate confidently breach both at the moment of occurrence and afterward. Honeypot contains fake data or service that look attractive to attackers but provide no real value to the organization. The standard methods of creating honeypot has certain limitation that may produce its effectiveness. First, attackers can identify static honeypot files if they lack sufficiently realistic attributes, such regular content updates and metadata changes. Second, traditional honeypot documents respond only to specific types of access and do not account for more sophisticated attacks, such as memory-based threats or file system evasion techniques. Additionally, this honeypot may generate a high number of false positive, especially when limited users or automate processed accidentally interact with them. This can overwhelm security system and complicate threat analysis. The subsystem is divided into key segments, each enhancing security protocols, making it more difficult to identify a honeypot file among other data. Upon detecting an authorized access, the system can automatically activate additional security measures, such as blocking a suspicious IP address, enabling advanced monitoring, or alerting cybersecurity analysis for immediate response. The decoy honeypot file is various locations, such as internal service, cloud storage, and public resource, allow tracking attacker activities across different network segments. This action help improve system reliability and enhance protection against unauthorized intruders. Dynamic honeypot files aim to eliminate the primary weakness of traditional honeypot documents. their static nature. Attackers can easily detect such files if the content or metadata remains unchanged for a long time. To prevent this, the file must continuously change while maintaining its passability. A distributed honeypot files system is designed to improve the effectiveness of honeypot documents by deploying them across different parts of the IT infrastructure. If honeypot file is located in only one place, such an internal service or server, an attacker may avoid interact with it, reducing its effectiveness. To make the honeypot more attractive and increase the likelihood of attackers' engagement, copies of the file should be created and distributed across various environments. Automated response to access attempt on honeypot files enable timely threats detection and help prevent further malicious activities within the network. If a honeypot file is open or copied, the system should immediately log this event, send a corresponding alert to security administrator, and take additional actions such as blocking the attacker's IP address or activate enhancing user activity monitoring. An essential step of configuration automating response to detect triggers. When a honeypot file is triggered, prevent script can execute the various actions, from notifying administrator to automatically collective intelligence or the attackers. This approach not only detect intruders attempts, but also help analyze attacker behavior, ultimately improve the system security over time. Compression and the calculation of methods efficiently. The table show that the proposed solution had a false positive rate of 10%, whereas the standard candy token files without enhancement rate 30%, indicating a high level of threat detection accuracy. The automatic IP blocking system for attackers was triggered in 95% of cases, ensured repeat threat response. Actively monitoring revelates that the system's average response time to access attempt was at 2 seconds, allow timely security measure to be taken. Seen in the table, at less 4 of the 7 triggers can be activated for each type of threats, helping to reduce false positive and ensuring responses only to potential threats. Does the present system maintain a table operation without overloading securities, resources, and its integration with cybersecurity mechanisms significantly reduce the risk of data compromise. This study introduces the architecture of the distributed system for detecting cyber threats based on dynamic honeypot files, combining automated monitoring, distributed honeypot deployment, and instant response to suspicious activity. The proposed approach effectively identifies a wide range of threats, including viruses, trojans, ransomware, and metamorphic viruses by utilizing dynamic changing files with realistic metadata. This work contributes to the development of the proactive cybersecurity methods, demonstrated that the combination of dynamic honeypot technologies and automation can significantly enhance the security level of modern IT and infrastructure. Thank you for your attention.
Thank you for your presentation. Okay, dear colleagues, do you have any questions, please? Okay, I have one question. Can you say what is your main impact concerning practical part of your research?
The proposed system can be integrated into corporate security frameworks to enhance the protection against attacks, social engineering, and automated cyber threats.
I see. So it's almost ready to use, yeah?
Actually, yes, and it's very flexible. This can be added to more part, what you like to do. It's like a constructor. You can use some part to analyze the threads, one part to, it's like in one, let's see here. You can add more triggers, what you like, if you have some specific threads to react on them.
Okay, thank you. Okay, thank you for your presentation. The next presentation, method for detecting malicious commands transmitted via images using steganography. Okay, let me share my screen because it will be video. Okay. And do you see the video?
Results and conclusion.
Yes, we see on video here.
I'm PhD student at Khmelnytskyi National University in the Department of Computer Engineering and Information Systems. Today, I will present the results of our research. The topic is a method for detecting malicious commands transmitted via images using steganography. This topic is very important today. Cyber threats are becoming more hidden and more complex. In our work, we study how attackers use images to hide malicious commands using steganography. The main goal of our research is to detect hidden threats by combining two approaches: frequency-based image analysis and monitoring system behavior after opening the image. This combination helps us to detect dangerous files more accurately. In this presentation, I will show the main parts of our research. We will start with the introduction and problem statement. Then I will explain the research objective and the detection process. After that, we will look at the system architecture, experiments, results, and conclusions. In today's digital ecosystem, steganography has evolved into a powerful tool used by cybercriminals to covertly transmit malicious commands, especially through images. These threats are hard to detect because they exploit the visual nature of files. Changes are often imperceptible to both users and traditional security tools. Real-world incidents such as the Stegano exploit in 2016 and the voucher banking Trojan in 2018 proved that steganography can be used to embed harmful code within seemingly harmless media. These examples underscore the urgency of developing smarter detection mechanisms, ones that combine frequency domain analysis with behavioral monitoring to uncover hidden threats before they execute on a target system. A common challenge in contemporary cybersecurity involves the detection of malicious commands embedded within graphic files using steganography methods. Adversaries modify pixel values or frequency domain components of images to transmit hidden instructions while remaining undetected by traditional antivirus tools or intrusion detection systems. Documented cases include the Stegano campaign, which hid malicious payloads in the transparency layers of PNG banners, and the Valtrak Trojan, which used JPEG images to store configuration data and control instructions. These types of attacks maintain the visual integrity of the image, making them difficult to detect through conventional visual or static analysis. Therefore, identifying such threats requires approaches that incorporate spectral analysis of image data and monitoring of system-level behavior, rather than relying solely on signature-based or heuristic detection mechanisms. The objective of this research is to develop a hybrid method for detecting hidden commands embedded in image files using steganography. The approach combines discrete Gaussian transform, DCT analysis of image blocks with system behavior monitoring. Extracted features are used for classification with a recurrent neural network to identify the presence of hidden data and determine the embedding method. This slide presents an example of a software implant that receives control commands through images using steganography methods. The implant implements dual-purpose functionality. On one hand, it performs typical operations on image files, such as resizing, optimization, or format conversion, which aligns with legitimate behavior of image processing software. On the other hand, when a specially crafted image is encountered, the implant extracts the hidden command and executes the corresponding action. Due to the absence of explicit indicators of steganography content and the presence of standard image-related functionality, such malicious code is difficult to detect using conventional analysis techniques. The detection process consists of several sequential stages. At the first stage, an input image is subjected to discrete Gaussian transform DCT analysis in order to evaluate statistical irregularities in the frequency domain. Next, behavioral analysis is performed to monitor the system's response after the image is accessed. The outcomes of both analyses are used during the feature extraction stage, where a multidimensional feature vector is formed. This vector is then passed to a classification model based on long short-term memory LSTM networks. As a result, the system produces two outputs: detection of the presence of hidden data and identification of the steganographic method used. The proposed system architecture includes several interconnected modules. First, the input image undergoes blockwise processing using the discrete Gaussian transform, which allows the extraction of high-frequency coefficient features from 8 by 8 pixel blocks. In parallel, the system monitors operating system activity after the file is accessed, including CPU load, process creation, and network behavior. All extracted features are combined and passed to an LSTM-based classification module. The system outputs two results: detection of a potential hidden threat and identification of the steganographic technique used for embedding. At this stage of analysis, the discrete Gaussian transform, DCT, is applied to each 8 by 8 block of the image. This transformation allows the original spatial domain representation, a matrix of pixel intensities, to be converted into a frequency domain representation. Each block of 64 pixels is thus represented by a set of 64 frequency coefficients, which capture the distribution of visual information across different spatial frequencies. The equation shown on the slide defines the two-dimensional DCT. It enables the decomposition of the image block into a sum of cosine functions with varying amplitudes and frequencies. The application of this formula provides a compact representation of the image data, where most of the energy is concentrated in the lower frequencies, while the higher frequencies are more sensitive to minor changes, including those introduced by steganography embedding. In steganography, hidden information is often embedded specifically in the high-frequency components, as these are less perceptible to the human eye. However, such modifications can still influence the statistical properties of the transform image. To detect these modifications, a number of statistical features are computed from the DCT coefficients of each block. Mean and variance describe the overall distribution. Skewness and kurtosis reflect asymmetry, and peakedness Entropy characterizes the level of unpredictability. These features are used to calculate an anomaly score, which quantifies the deviation of a given block from typical clean image patterns. This score is later used in the classification stage to infer the presence of hidden data and identify the potential steganography method. This stage involves behavioral analysis of the system after the image file is accessed. We monitor key indicators such as CPU usage, background process activity, and network behavior. To determine whether the system response deviates from typical patterns, we apply statistical anomaly score. This allows us to detect unusual changes that may indicate hidden command execution triggered by the image. At this stage, we combine features from two sources: frequency analysis of the image and system behavior monitoring. These features are used to build a multi-dimensional vector that represents the image and its impact on the system. The formula on the slide calculates the total change in process activity after the image is opened. If the difference exceeds a defined threshold, it may indicate the execution of hidden code. The complete feature vector is then used as input for an LSTM-based classification model to detect the presence of embedded data and identify the steganography method. To evaluate the effectiveness of the proposed method, a detection system was trained and tested using synthetically generated data. 3 publicly available datasets were used: BOSS-based, StegoApp-DB, and Alaska2, containing both clean and stego images with various embedding strategies. All images were converted to a unified format, JPEG, with a resolution of 512 by 512 pixels, and metadata was removed to eliminate potential bias in classification. To generate stego samples, we use 4 widely known tools: StegHit, F5, GetSteg, and OutGet. These tools implement different steganographic algorithms, enabling the model to learn to distinguish between various hiding techniques. The resulting dataset was used for both training and evaluation of the model. The system was tested on 2 tasks: detecting the presence of hidden data and classifying the steganography method used in each case. This slide presents the accuracy results for steganography content detection obtained during synthetic testing. The accuracy metric represents the proportion of correctly classified samples in the test dataset, considering both true positives and true negatives, as shown in the formula. The proposed method achieved 93.4% accuracy, outperforming widely used deep learning models. SRNet 89.3%, ShoeNet 87.2%, and YedrujNet 85.8%. These results were obtained under controlled synthetic conditions. The improvement is due to the integration of DCT-based spectral analysis and behavioral features that reflect system activity after opening the image. This approach enhances the system's ability to detect hidden commands, even in the absence of visual indicators. This slide presents the recall results, which reflect the model's ability to detect all actual cases of steganographic content. The proposed method achieved 90.8% recall for steganography detection, which exceeds the results of SRNet 85.6%, ShoeNet 82.1%, and YedrujNet 80.2%. For the task of embedding method classification, the recall reached 78.2%. The reduction in false negatives was made possible by including behavioral features, which help detect hidden command execution even when the image itself shows minimal visual changes. In conclusion, the proposed hybrid detection method demonstrates improved accuracy and robustness in identifying hidden commands embedded in images. By combining DCT-based spectral analysis with system-level behavioral monitoring, The approach effectively detects threats even when there are no visual anomalies present. The method outperforms well-known deep learning architectures such as SRNet, ShoeNet, and YaDruchNet in both detection accuracy and recall. Future research will focus on enhancing the detection system through several directions. First, we aim to integrate transformer-based models capable of performing deeper and more precise frequency analysis in image data. These models may capture subtle spectral patterns that are hard to detect using CNN or LSTM alone. Second, improving the detection of passive hidden threats will require advanced behavioral profiling, allowing the system to identify anomalies even in the absence of direct. Another important direction is incorporating metadata and file structure analysis, which can increase detection robustness and resistance to obfuscation techniques. We also plan to develop hybrid models that combine machine learning, statistical inference, and cryptographic methods. Such models may improve both threat classification and attribution. Finally, the training base will be expanded with more diverse data sets, including real-world examples, to enhance generalization and adaptability of the system. Thank you for your attention. I will be happy to answer your questions or discuss possible directions for future research. Good afternoon.
Okay. Dear colleagues, let's move on. Okay, the next presentation determining the critically assessment of defects on wind turbine components detected by UAV sensors. Who will be presenting?
I am.
Sergey, please.
A moment.
You have 15 minutes.
Good afternoon, dear colleagues. My name is Sergey Svistund, and I am PhD student at Khmelnytsky National University. On behalf of my authors, I am pleased to present our work titled Determining the Critically Assessment of Defects on Field Power Plant Component detected by UAV sensors. In my presentation, I will cover the following topics: motivation and the states of the art, objective on the research, method on the materials, experiments and results, discussion, conclusion. Wind turbines operate in remote environment, making defect detection challenging. Traditional inspection methods are often inaccurate, leading to main station daily. Current approaches rely on deep learning and computer vision to process UAV sensor data. However, challenges main is multi-sensor data integration, aspect system consistency and computational efficiency of hybrid models. The research aims to develop a robust framework for detect critical assessment using UAV collected data. The approach combines deep learning for defect detection and physiologic for quantity evaluation, B integration, RGB and thermal imagery, detection accuracy, enhanced minimized classified error. The approach is tested in real-world conditional and compares to existing solutions. This process approach integrates multi-sensor UAV data deep learning models and fuzzy logic for detect reassessment. UAV captures images to process it to extract the fact features. These are analyzed using expert Bayesian model. Fuzzy logic is applied to generated final critical scope, improving detection accuracy and interpretation. Environmental factors such as terrain and wind condition affect UV stability, and data fusion quality approach is studies under real condition to real world conditions to ensure robustness. Challenges include fine sense flying stability and obtaining high quality images to the fact analysis. Wind power plant components exhibit favorite defect type influence to structural complexities like lighting and inspection angles. The study highlighting the importance of multispectral data in recovering these challenges. Details comparisons of the fact characteristics help refine detection methods. The fitting of the proposed method is demonstrated by comparing RGB and composite images. Result indicates this combining spectral data improves defect visibility and classification accuracy, reducing false positive and undetected issue. Different defect detection models are evaluated based on accuracy, precision, recall, and ROC-AUG. The ensemble approach combining yellow A version 8 with Cascade R CNN achieves the best performance, improving recall and overall detection reliability. Summarized performance metrics confirm the superiority of the sample approach over single mode methods. The integration of multiple detection models enhanced defect identification across various categories. Using compromise RGB thermal images significantly enhance defect detection. This is particularly beneficial for identifying overheading and all the hidden defects. Performance metrics show notable improvement compared to standard RGB images. Visual performance scores confirm the advantages of multispectral images. The combined approach leads to sustained gain in accuracy, recall, and precision, and ensuring better defect identification and assessment. Fuzzy logic-based severity assessment assigns score to defects based on physical attributes and thermal temperature variables. The result aligns closely with expert evaluation, providing a relative approach for the defect prioritization in station planning. The distribution of severity scope illustrated the classification of defect intercritically levels. The strong correlation with expert assessment confirms the reliability for proposed approach. The proposed approach improved defect detection with AI-driven multi-sensor data fusion, multispectral imaging, enhanced accuracy 16.5%, while the assembly models achieves 94% recall, reducing detected defect. The main advances of this approach include the high defect detection, reliability, automated severity assessment, and reduced human dependency. However, challenges such as high computationally require and UAV sensor calibration must be addressed to ensure practical scalability. With the logic allow for an adaptive severity assessment system, this combines physical defect parameters with expert evaluation, resulting in strong correlation between automated and expert assemblies. Key challenges include sensor calibration, validation for USV operation, and high computationality demands for real-time ensemble analysis fuzzy scoring. This summary integration multispectral UAVs data, deep learning, and fuzzy logic significantly improves defect detection. The approach reducing classification error and enhanced predictive main sense. Challenges remain insertion calibration and computational cost. Future research showed enhanced real-time processing, AI models, and sensor fusion technicals. Thank you for your attention.
Thank you, Sergey. Dear colleagues, do you have any questions?
Yes, I have one question, please.
Yes, Pablo, please.
For your experiments, have you used third-party datasets? If so, which ones have you used? If not, in what way have you trained your neural network? Thank you.
Well, if I may, as a co-author, I would like to answer this question because I was more involved in this process of detecting and assembling. If you may, of course, directly answering the question, no, we did not use any additional data sets beyond the ones we collected ourselves during conducting the experiments, which is we describe in one of our sections 3.5, if I'm not mistaken, of our manuscript. Actually, we trained the individual neural networks like YOLO version 8 and Cascade RCNN, etc., using the RGB and thermal images gathered and provided to us by a wind farm maintainer. In this case, the ensemble was then created by combining the detection outputs from these individuals' trained models to improve overall detection accuracy and recall, particularly by exploring the strengths of different models on diffused multispectral data. Specifically, YOLO version 8 and Cascade RCNN showed the best results. And in short, no third-party dataset were used. We just conducted experiments on one manually crafted dataset. Thank you.
Thank you. Thank you.
Thank you. Okay, let's move on. The next presentation is presentation of our team. Let me share my screen. Okay, I have mission today to present some results of our team. And on this stage, we have some approaches devoted to models of distributed heterogeneous system resistant to leakage or confidential information. So here is agenda. We have some motivation. We will focus on some challenges, ideas, solutions, of course, and results and future work. Actually, talking about distributed systems today, we have a huge amount of challenges. First, important task, it's computing require flexibility, scalability, and of course, high performance. Also, such system play key role in cloud computed AI and big data processing. We need interactions between all of components in such distributed systems. Taking into account these, we have to talk about IT infrastructures, and they mostly consist of servers, network, storage, some applications, environments, and to combine it, we have to talk about interconnectivity, vendor diversity, multiple protocols usage, etc. To do this, it requires standardization, coordination, and of course, cybersecurity issues. One of these is data leakage, because these risks may diverse environment. And the major risk is inconsistent security policies, complex access control, vulnerable nodes and network attacks, insider threats, and even human errors. To do this, to avoid this, we have to use and combine and develop new architectures for secure distributed systems. It means that we need for efficient resource management security in modern distributed systems. It means we have to construct end-to-end encryption for data and transit and zero trust model construction as well. It means we have to minimize data leakage risk, enhance compliance, and improve system resilience at all. At the base for constructions of such a distributed system, we have the possibility to use a multi-agent system. They say multi-agent security architectures, because they have a lot of benefits. First, it's decentralized nature, because it reduces risk of central control and compromise, real-time monitoring of anomalies and data access, as well as dynamic response to secure threats. To do this, we can construct a set of security agents in such distributed environments in order to monitor traffic, access right verification, monitor potential data leaks, sharing risk environment, information between agents, and it allows proactive security adjustments based on threat patterns. So the idea is to construct a novel model for a distributed system that enhances resistance to data breaches by leveraging a multi-agent approach. This model have to integrate autonomous security agents responsible for real-time monitoring, anomaly detection, and dynamic access control. For this purpose, some framework formalizing agent interactions, decision-making strategies, and information flows were developed. So such model of infrastructure as a multi-agent system includes set of components. It's a set of agents actually that are user agents that interact between users that perform tasks, processing requests, information, storage, supporting decisions. Set of service agents that provide access to services, set of monitoring agents, it's a security agents, and set of communication agents that are responsible for exchanging data between different agents using communication protocols. For this purpose, we defined set of agent states, set of actions that agent can perform, set of agent strategies or policies that are determined by the choice of actions in particular state. Also, we have to use some utility function or objective functions that define the agent's goals and set of resources available to the agents, as well as communication model. This defines how the agent can exchange information with each other. For this purpose, we take into account the model set of environmental dynamics function, interaction between the agents, and as a set or the state for each agent changing according to this function. That includes state of agent, action chosen, information received, and the result of actions between the decision. The main goal is in optimization of functioning of agents, and for this we are using utility function. And collective function also is introduced. The description of distributed model is presented at the local optimization. To ensure balance in the system, the interaction of agents can be described through a mesh equilibrium when no agent can improve its outcome by changing only its own strategy. To achieve the goal, we can use consensus algorithm, which is taking account decision of all agents presented in the multi-agent system. So, as a result, we have to monitor and ensure the data integrity. For this purpose, special behaviors are to be inspected and may be presented as a vector behavioral parameters. Also, we present the anomaly detection function, and such model included the data integrity verification model and access control model. Based on the proposed model, some experiments were held. For this purpose, the first one was multi-agent stability test that included agent analyzation. It means that we have to perform some interactions possibilities with environment. The first stage was to execute performance determining, including some metrics such as query processing time, resource usage, false tolerance level. Then we executed stability tests. It was a simulation of failures for individual system components. And the last stage was the test concerning adaptability, its possibility to adapt system to some new conditions after some failure, attack, etc. So the idea was to take into account such metrics as request processing time, system throughput, agent load, failure tolerance, scalability, recovery time, and communication efficiency. Here you can see some table of experiment result. The second part of experiments were devoted to IT infrastructure data leak attack test. We have involved three types of scenarios for executing an experiment when attacking an infrastructure. To evaluate a multi-agent with data monitoring and protecting function was determined with the time of attack, detection accuracy, speed of data integrity verification, and success of recovery after an attack. The first scenario was SQL injection data leak attack. It means that the attacker carried out some SQL injection attack in attempt to gain an unauthorized access to sensitive information by inserting malicious queries into form input fields. Also, for this purpose, the monitoring agent, the security agent, and the integrity agent were involved. You can see the results of time, detection accuracy, integrity check time, and rate of successful recovery, for example, for 10 experiments. The next scenario was devoted to malicious script, which is downloaded to the server that secretly copies sensitive file and sends to an external server. Also, that 3 monitors were involved for this purpose. Here the result of test. This scenario included data theft due to a phishing attack. The attacker sends an email with a fake link that directs the employee to a malicious site to enter credential. And monitoring agent, security agent, and integrity for credential for the user's login history were checked this purpose. And result of the test is presented on this slide. Also, there was the first, actually, one more scenario. It's a brute force attack using stolen credential, where attackers tried to guess administration password by repeatedly tried to log in. It's brute force attack, yes, and here is the result of such an attack. As a conclusion, we have to note that novel model for distributed system was presented, and it is based on the multi-agent approach usage. Feature fork, it's an integration of some machine learning technologies for optimization of the agent-based security mechanisms, exploration, some adaptive approaches for prediction and response, and develop maybe blockchain security frameworks to enhance trust and integrity in distributed environments. Thank you for your attention. Dear colleagues, do you have any question? Okay, if you have no questions, thank you for your presentations, for your interesting speeches, for your questions, for your answers. This was the last presentation for today. Thank you for your attention. And according to schedule, we have award and close ceremony at 17:15. Yes, so we have a small break. Please attend at awards and close ceremony. See you in half an hour. See you. Thank you.
See you. Goodbye.
See you.
Dear colleagues, let's start our last meeting for today. I am glad to welcome you to the final meeting of our 6th International Workshop of Intelligent Information Technologies and Systems of Information Security, Awards and Close Ceremony. Let's summarize. The program of our workshop included welcome and plenary session, 2 sections, and awards and close ceremony. We had 17 presentations on section first, Intelligent Information Technologies, and 12 presentations on section second, Systems of Information Security. All accepted papers were presented at workshop. The representatives of 39 institutions took part in our workshop, includes 21 universities from around the world and 18 Ukrainian universities. I want to greatly thank my co-chair, Professor Oleg Savenko, chairs of the International Program Committee, Professor Sergei Lysenko and Dr. Peter Popov, organizing committee chairs, Dr. Olga Pavlova and Dr. Science Elizaveta Hnachuk, to our information partner, the public organization Ukrainian Scientific and Educational IT Society, to all section sessions co-moderators, Dr. Olga Pavlova and Professor Sergei Lysenko, to all my colleagues, our lecturers, and of course, all participants of our workshop. Without you, without your paper, without your presentations, the workshop would not have happened. We will be prepared and send to all speakers the certificate of participant. You can, second type certificate is award certificate. Now we want marking the best reports, the best presentations, will special certificates. One moment. And Vitaly Alexeyko is awarded a special certificate for the one of the best presentations in section first, Intelligent Information Technology.
Thank you very much.
Alexander Kirichenko is awarded a special certificate for the one of the best presentations in section first, Intelligent Information Technologies.
Thank you very much.
Andriy Shukta is awarded a special certificate for the one of the best presentations in section first, Intelligent Information Technologies. And Taras Elyarnik is awarded a special certificate for the one of the best presentations in section first, Intelligent Information Technologies.
Thank you.
Vyacheslav Kovtun is awarded a special certificate for the one of the best presentations in section second, Systems of Information Security. And so Maxim Prodovus is awarded a special certificate for the one of the best presentations in section second, Systems of Information Security. Best papers and best presentations and greetings from the speakers. All 29 accepted papers will be sent to the SEUR-VS journal for consideration as soon as possible. We will hope that SEUR will accept our proceedings, and we will keep in touch with the authors and will inform you about the milestones of publication of our papers. I want to inform you that we plan to hold a 7th International Workshop on Intelligent Information Technologies and Systems of Information Security next year. We believe that Ukraine will win, and next year we will be able to meet live, not only online, and within the walls of Khmelnytsky National University. We are waiting your interesting papers and presentations next year. Maybe someone has questions, propositions, comments, recommendations. Maybe someone wants to say a few words in English, in Ukrainian. Please welcome, colleagues.
Thank you for all presentations. It was very interesting as for me, and I hope for further cooperation. So till next our meetings. Hope offline.
Thank you, Dali. More comments, colleagues?
Yeah, I also want to say thank you, organizers. This is a good place to share our ideas, findings, maybe new approaches and new ways where we wanna move to in the future. So also this is a kind of good event, and yeah, I really appreciate this. Thank you.
Thank you, dear Alexander. More comments?
If you may, Tatiana Alexandrovna, I would like to say a few words. Thank you very much for awesome organization, as always. I consider this conference probably one of the best workshops within the SU community because I participated in many of them, and this level of organization is quite astonishing, especially compared to other workshops. Thank you very much for this great opportunity to present our work.
Thank you, dear Pavlo. More comments, colleagues?
Yeah, I also want to thank you from our team. That was really interesting meeting, and thank you for the opportunity from us to share our study results. Thank you.
Thank you, dear Taras. More comments, colleagues? Sergey, Professor Lysenko, please.
Yeah, sure. Dear colleague, as we come to the end of our workshop, I'd like to say some moments, to highlight some moments. Firstly, I'd like to express my deepest gratitude to speakers, presenters, my colleagues who took part on all these events. And I'd like to dedicate it to all you, to our ideas, to our ideas, to technologies, to science. And now, concluding, our collaboration does not end here, because I suppose that we will continue our discussion, build ideas, communication, make new connections today, to future, to our new partners. And thank you for being here to be a part of our journey. Looking forward to see you next year in our workshop. Glory to Ukraine, glory to heroes. See you.
Thank you, dear Sergey. More comments, colleagues? No comments. On this, we finish our awards and close ceremony and our 6th International Workshop on Intelligent Information Technologies and Systems of Information Security. And so, see you soon. We are waiting for you next year and on our other workshops this year. Bye-bye. See you.
Thank you. Goodbye.
Bye-bye.
Goodbye. Have a nice day.
Bye.
See you
Have
next
a nice
year.
day.
Bye.
Bye.